Salam, ጤና ይስጥልኝ እንደምን ዋላችሁ እንደምን አመሻችሁ ሳኒ ነኝ ከቫይብራኒየም ሪሶርስስ ፋውንዴሽን የዛሬው ፕሮግራማችን የሚሆነው ሼር በተደረገው ፔፐር ላይ የመጀመሪያው ጤና ይስጥልኝ እንደምን ዋላችሁ እንደምን አመሻችሁ ሳኒ ነኝ ከቫይብራኒየም ሪሶርስስ ፋውንዴሽን የዛሬው ፕሮግራማችን የሚሆነው ሼር በተደረገው የቫይብራኒየም ሪሶርስ ፋውንዴሽን ከዶበርቲ ሳይንስ ፋውንዴሽን ጋር በመተባበር ዶበርቲ ሳይንስ ካፌ ጋር በመተባበር ከይቅርታ ጋር የምናዘጋጀው ፎርትናይትሊ በየ15 ቀኑ የምናዘጋጀው ሪሰርች ሜተድ ፕሮግራም የመጀመሪያው ክፍል ነው ዛሬ የሚሆነው ሰው በዚህ በየ15 ቀኑ በሚዘጋጀው ፕሮግራማችን ላይ ሶስት ዋና ዋና ነገሮችን ማየትን ሞክራለን የመጀመሪያው ፐብሊሽድ የሆኑ ፔፐሮችን ፕሬዘንት በማድረግ ስለ ፔፐሮች ያለንን አንደርስታንዲንግ እንጨምራለን ኮላቦሬሽን እንፈጥራለን በሁለተኛ ስለ ሜተዶች ዲስከስ እናደርጋለን የተለያዩ ኮንሰፕቶችን እንወያይባቸዋለን ከነዚህም መካከል ኤፒዴሚዮሎጂካል የሆኑ ኮንሰፕቶችን ስታቲስቲካል ሜተዶችን ማቴማቲካል እና ኢኮኖሚክ ኮንሰፕቶችን እንደዚሁም ደግሞ ከዳታ ሳይንስ የተለያዩ ኮንሰፕቶችን የምንዳስስ ይሆናል በሜተድ ሴሽናችን በሶስተኛው ፕሮፌሽናል ዴቨሎፕመንት ነው በአብዛኛው ከስኮላርሺፕ ግራንት አፕሊኬሽን እንደዚሁም ደግሞ ኮንፈረንሶች እና ከስራዎች ጋር የተገናኙ ኢንፎርሜሽኖችን ሼር የምናደርግ ይሆናል በየሳምንት በየ15 ቀኑ እንድትከታተሉን እየጋበዝ ወደ ዛሬው ፕሮግራም ከመሄዳችን በፊት ዛሬ ለእናንተ የመረጥነው ፔፐር የመጀመሪያ ፕሮግራም እንደመሆናችን ትንሽ ኦርጋናይዜሽናል ግሊች ሊኖር ይችላል ትታገሱናላችሁ ተስፋ አደርጋለሁ seasonal malaria vaccination with or without seasonal malaria chemo prevention ነው ሁሉ ጊዜ ዲስከስ የምናደርጋቸውን ፔፐሮች እንደዚሁም ደግሞ ኮዶች አርን በደንብ እንማራለን ብለን እናስባለን በዚህ ፕሮግራም ሁሉንም አር ኮዶች ሲንታክሶች እንደዚሁም ደግሞ ፔፐሮች እና ስላይዶች ቫይብራኒየም ሪሶርስስ ቻናል ላይ ሼር የምናደርግ ይሆናል ስለዚህ ቀድማችሁ ፕራክቲስ ማድረግ የምትፈልጉ ማንበብ የምትፈልጉ ቫይብራኒየም ሪሶርስ ቻናል ላይ ሄዳችሁ ሁሉንም አር ኮድም ስላይዶችንም እንደዚሁም ፔፐሩንም መውሰድ ትችላላችሁ ይሄኛው የዛሬውን ፔፐር ሼር አድርገናል ምን ያህሎቻችሁ እንዳነበባችሁት እርግጠኛ አይደለሁም ምናልባት አይዲያው እንዲኖረኝ ከናንተ ውስጥ ይሄንን ፔፐር ያነበበ እጃችሁን በማውጣት ብታሳዩኝ ደስ ይለኛል ምን ያህሎቻችን አንብበናል እጃችሁን ማውጣት ትችላላችሁ ላይ እዛ ላይ ሪአክሽንስ የሚለው ላይ ሄዳችሁ ልክ እንደዚህ እጅ ማውጣት ይቻላል ኦኬ can you show me ምን ያህሎቻችሁ እንዳነበባችሁት ታሳዩን ትችላላችሁ እያየሁኝ አይደለም ሰው የዛሬው ፕሮግራም እንዳለ ሆኖ ምናልባት ለወደፊት ዲስከሽናችን የተፋጠነ እንዲሆን አንበባችሁ ብትመጡ የተሻለ ነው ለማንኛውም ለዛሬ እኔ ፕሬዘንት ስለማድረግ ለዛሬ እንደ ነገሩ እንቀጥላለን ማለት ነው ሰው ፕሮግራማችን በሶስት ክፍል የተከፈለ ነው የሚሆነው ሰው የመጀመሪያው ፔፐር ፕሬዘንቴሽን ነው ፔፐሩን ፕሬዘንት አደርግላችኋለሁ ከዛ በመቀጠል ስታቲስቲካል ሜተዶችን የምናይ ይሆናል የዛሬው ፔፐር ሞር የሚያተኩረው ራንደማይዝ ኮንትሮል ትራያል ላይ ስለሆነ የመረጥኳቸው ሜቶዶሎጂ ዲስከሽኖችም ራንደማይዝ ኮንትሮል ትራያል እና ሁለት ስታቲስቲካል ኮንሰፕቶች ናቸው የመጀመሪያው ሚን ነው ሁለተኛው ደግሞ ኮንፊደንስ ኢንተርቫል ምንድነው የሚለው ነው የምናየው ሶ ሁለቱም ከፔፐሩ ጋር ስለሚገናኙ አጠር አድርገን የምናይ ይሆናል ፔፐሩ ላይ ብቻ ኢንትረስት ያላችሁ ፔፐሩ ላይ ትቆያላችሁ። የመጀመሪያዎቹን 25 ደቂቃ ፔፐሩ ላይ እናጠፋለን። ሜተዱ ላይ ኢንተረስት ያላችሁ ወደ በኋላ አካባቢ ትቆያላችሁ ማለት ነው። ሜተዶቹን ስናይ አር ኮድ እና አር ዳታ ሼር አድርጌያለሁኝ። ምናልባት አር ኢንስቶል ካላረጋችሁ አርን ኢንስቶል አድርጉትና ፕሮፐርሊ እየተማርን እንድንሄድ እናንተም እየሞከራችሁት። ብዙ ጊዜ ስታቲስቲካል ሶፍትዌሮች ስኪል ናቸው። ስለዚህ የማትሞክሩት ከሆነ ለመማር ያስቸግራልና እናንተም እየሞከራችሁት እየሰራ ነው እንድንሄድ በዲስከሽናችን መካከል ኢንስቶል ያደረጋችሁ ካሉ ዳውንሎድ አድርጉና ኢንስቶል አድርጉት። ኢንስቶሊንግ እና ዳውንሎዲንግ ኢንስትራክሽኖችን ሼር አድርገናል። ቫይብራኒየም ሪሶርስ ፋውንዴሽን ቴሌግራም ቻነል ላይ ታገኙታላችሁ ሙሉ ኢንስትራክሽኑ። እኔ ደግሞ በኋላ ስክሪን ሼር ማድረግ ይሆናል። የመጀመሪያው አንሚዩት ላርጋችሁና ራሳችሁ አንሚዩት ታደርጉልኛላችሁ። መናገር ስትፈልጉ ጥያቄ ሲኖራችሁ በማለት ገባላችሁ ማለት ነው። ወይም ደግሞ እጃችሁን በማውጣት ካሳያችሁኝ ያም ያስኬዳል። ይቅርታ ስክሪን ሼር ለማድረግ እየሞከርኩ እምቢ እያለኝ ነው። ሆፕፉሊ should work. ስክሪን ይታያችኋል? ምልክት ስጡኝ። አትታዩኝ? ስክሪን ይታያችኋል?
አዎ ይታየናል።
ኦኬ አመሰግናለሁ። እሺ ኦኬ እሺ የመጀመሪያው ሴሽናችን የሚሆነው I'm going to use English ሌሎችም ተሳታፊዎች ስለሚኖሩ so the contents of today's presentation would be first is the trial paper on malaria vaccination, and then we will have a few minutes to discuss epidemiological concepts, and then we will follow them up with the statistical concepts, and we will have some updates on calls, conferences, and grant applications as well as jobs, and then we will introduce the next session. So this paper is published in the New England Journal of Medicine in 2021. It is a seasonal malaria vaccination with or without seasonal malaria chemo prevention. It was a randomized double-blind study. Why we chose this paper? Because this was the first vaccine trial that WHO has considered, and the vaccine was approved by WHO in certain parts of Africa. So it was a milestone research in malaria prevention. As you know, in many parts of the sub-Saharan Africa, malaria transmission is highly seasonal, so it's limited in few months across the year. So what I would like to tell you here is that I will also try to summarize the paper in such a way that how you should write a paper. Like what should you include in the introduction? what should you include in the methods, in the results, as well as in the discussion. So the way my slides are organized is such that you will also learn how to write paper. So the first slide will describe the problem. So it gives information about the problem or the idea, and which is malaria and chemo prevention. So seasonal malaria chemo prevention involving monthly administration of sulfadoxine, pyrimethamine, and amlodipine to young children during the transmission season is highly effective in preventing malaria. Despite widespread use of SMC, as well as access to effective diagnosis and treatment options, the burden of malaria in sub-Saharan African countries is still very high. You see, here is the problem. So kind of mentioned what's been done and what is the problem, but here is like a gap. And in a multi-country study involving Malawi, Kenya, and Tanzania, as well as Ghana, a phase 3 trial involving young children, the malaria vaccine, which is called RTSSAS01E vaccine, reduced the incidence of malaria, and it's being evaluated in implementation studies. The protective efficacy of this vaccine is higher during few months after vaccination, but it wanes or it goes down, although not completely, after a few months. So this is another gap. RTSS vaccine could be used as a seasonal vaccine in areas where malaria transmission is highly seasonal, with an annual booster dose administered just before the start of the transmission season. So where the trial was conducted, it's in Burkina Faso and Mali. The transmission season is from August through November or December. So vaccines are usually given in June or July. So as you can see, it is a problem. So they tried to do a study, and the study was a double-blind randomized control trial. So they collected information on households with children who are 5 to 17 months of age on April the 1st, 2017, because this date is where the trial will start. And they were remunerated. So this provides the sampling frame. Inclusion and the exclusion criteria were applied, and written informed consent was obtained from parents or their guardians. And then an independent statistician randomized children to one of the 3 groups. So the first group is children who are receiving SMC chemo prevention only. The second group is children who are going to receive the vaccine only. And the third group is children who are going to receive the combination of the chemo prevention as well as the vaccine. So as I said before, it is a randomized control trial, and randomization was using permuted block of these characteristics. And the randomization was only accessible to the chief pharmacist who provide the vaccines and the medication. All other investigators, including the clinicians and the stats, as well as the trial staff, they were blinded. Remember, this is a double-blind study. So patients were blinded as well as investigators were blinded. So they were unaware of treatment assignments until the log database for analysis has been archived or open for data analysis by the Data and Safety Monitoring Board in June 2020. And this is how the trial looked like. So this first part of the trial shows you the first 3 years, which refers to this paper. And then there was another paper which I shared in the Telegram channel, which looked at the 5-year outcome. So we are not looking at these 2 years. We are only looking at the first 3 years. So we said that children were randomized into 3 groups. The first group is the SMC group alone. So they do have control vaccines, as you can see here. And the second one is RTSS vaccine alone group. So they do have placebo SMC. And the third group is they do have a combination of both RTSS and SMC. So Vaccines were provided. So the first 3 vaccines were given in April, and these were priming doses. And then every other month, so every other year, just before, this is the boxes on top that you see the transmission season. So before the transmission season, there is a booster dose every year. So 3 priming doses, and then in 2018, there is 1 booster dose, and in 2019, there is 1 booster dose. So children in the control vaccination group, they have, so the first year, they do have rabies vaccine, and the 2018 and 2019, they do have hepatitis vaccine. Whereas children in RTSS group, they do have the 3 priming doses in the first year, 2017, and they have the booster dose, 1 in 2018, booster dose 2, 2019. Children in the combined group, they have the priming doses as well as SMC, the real SMC, not the placebo one, but also they do have a booster dose in 2018 and another one in 2020. And the primary outcome for this trial was uncomplicated clinical malaria. Uncomplicated clinical malaria was defined as fever plus Plasmodium falciparum parasitemia of 5,000 plus per millimeter cube. So fever is measured as a temperature of 35.5 degrees centigrade or a history of fever. And then there were additional secondary outcomes, which includes hospital admission with malaria, deaths from malaria, and malaria parasitemia. The statistical analysis. So the rationale of the trial sample size was described in there. This is a non-inferiority and a superiority trial. We'll come to discuss what it is. The primary analysis was performed in the modified intention to treat population. So children were analyzed as if they were assigned to their groups. But the per protocol population included children who received all doses of SMC and RTSS alone. So we will discuss what ITT and per protocol analysis means. Secondary outcomes were assessed only in the modified ITT children. So the outcome was measured as an outcome as well as time. So the person time, here the person time, so it's not just having malaria or not, but it is defined as having malaria as well as when. So there is a time component to it. So the event is a time to event. So the outcome is a time to event outcome. And then you can imagine what kind of model they are going to use. So the person time at risk. So this is the time during which the children is at risk of developing our outcome. This was calculated from the date of first vaccination until the date of days or date of permanent immigration or date of consent withdrawn, the date last seen if children are lost to follow-up or temporary travel, or the end date of the trial. So whichever comes first, that would be the first time. So you still can hear me, right?
Yes.
Okay, thank you. So yeah, so like I said, the outcome was defined as a time to event analysis. I will say this in Amharic. አንዳንዴ አውትካማችን ምን ይሆናል? ማላሪያ ይይዘዋል ወይም አይይዘውም ብለን ዲፋይን እናደርጋለን። አንዳንዴ ግን ይይዘዋል አይይዘውም ብቻ ሳይሆን መቼ የሚለውን እናካትታለን። ምክንያቱም ታይም ኢዝ ኢምፖርታንት አይደለ? people die ግን ኢምፖርታንቱ ምንድነው? when they die ነው። ታይሙ ኢምፖርታንት ነው። ስለዚህ in this trial the outcome was time to uncomplicated malaria ነው። ስለዚህ they could have malaria, yes or no, but also the time to event is important. So that's why the primary model was the Cox regression model, adjusting for trial center, which is either in Burkina or Mali. And this model also accounted for robust standard error. As you can imagine, malaria is a recurrent outcome. It's not like HIV where children will develop one event and that's it, right? So malaria could come again and again and again. So these kind of events are called recurrent outcomes. And the way we analyze recurrent outcomes also differ. So that's why there is a robust standard error to account for those recurrences. And then protective efficacy, which is defined as the percentage difference in total number of events over the trial period, 3 years, was estimated as 1 minus the hazard ratio. As you can imagine, the Cox model provides us with hazard ratio. So incidence rate differences as well as incident rate ratios were also calculated for the other outcomes, the secondary outcomes. So when you have a trial, this is the diagram of the flow. So we have 3 groups and some children could be lost to follow-up. So this is how it flows. So at the end, these children were available for analysis. By the way, that's called the consort diagram. So it's always required. So this is the first table. So I'm going to look at the first few rows only. So the first column in here, it shows you person year at risk. So this is the time during which the children are at risk of developing the disease. So the first one is the chemo SMC alone group, the vaccine group, and the combination group. And the first row is the person time at risk. And the second row is the number of events. For example, 1,661 events were recorded in children who are in the SMC group during the 3 years. And this number was recorded in children in the vaccine alone group during the 3 years. So from here, one can calculate hazard ratio. Hazard ratio would be the hazard in this group, for example, compared to the reference hazard. So that would give us hazard ratio. And incidence is the third row. Incidence was calculated as events divided by the person years. And then there is a 95% confidence interval. And here, so the chemo prevention alone group was a reference group, and then the vaccine alone group was compared with that. So the protective efficacy was around 10 compared to the reference, whereas the combination of SMC and vaccine was about 62%. And the last row compares the combined group with the vaccine alone group. So in this comparison, the children in SMC groups were not included. So the second 2 rows, they compare results by country. So in Burkina Faso and Mali, as you can see, the effect of vaccine alone compared to the reference was lower in Burkina, but it was higher in Mali. And the last 3 rows, they compare vaccine efficacy in the 3 years. So in the first year, vaccine efficacy of the combined group was very high, but it goes down as we go across the years. The last column compares vaccine efficacy of the combined group with the vaccine alone group. And as you can see, when the first year was higher efficacy, 72%, and then it gets lower, around 60%, and then it gets lower, 52%. So the efficacy decreases across the years, but we still have that efficacy detected. I'm not going to spend time on this one. So this is for the secondary outcomes, hospitalization for different malaria, as well as days. You can see that there is effect, especially the combined group is superior to the reference group. So you can see that in this, you have seen in this paper. So this is also the other secondary outcomes. We still see that impact. So discussion. So the first part of a discussion of a paper usually summarizes the result. So this is how they did in this paper. So the result of this trial shows seasonal vaccination with RTSS was non-inferior to 4 annual courses of SMC in protecting children against uncomplicated clinical malaria in the 3-year period. And the combination of the vaccine as well as SMC was superior to vaccine-only group as well as SMC alone group with respect to reducing incidence of uncomplicated malaria, as well as the secondary outcomes, hospital admissions and deaths from malaria. RTS vaccine priming and booster regime was not associated with any concerning pattern of side effects. And here you see that the paper tries to relate to other papers that has been done. Febrile seizures developed in only 5 children who received the vaccine, which is a finding consistent with other vaccine trials. And no cases of meningitis were detected, and no imbalance in days across the sex was detected. Meningitis and days were the common side effects of this vaccine in children in the previous study. Among children who undergone randomization in the 3 groups, 40% of the vaccine alone, as well as the combined group, didn't attend the first vaccine. So they were not included in the analysis. So this could have introduced bias. So this is one of the limitations of the study. And then they come to the strength of the study. The trial is a very big trial, very powerful, high retention rate, only 40% loss to follow-up, careful assessment of the causes of hospital admission and days, and the consistency of effect estimates against different outcomes. As you've seen in the table, the vaccine has effect in all the groups. The drugs currently used in the SMC regime here, the 3 drugs, they are effective in trials conducted elsewhere. However, if resistance to this drug increases without available alternative chemo prevention, seasonal malaria vaccination could provide a potential alternative. So this is the suggestion or recommendation. So the combination of SMC and vaccine alone provides a promising approach to the prevention of malaria in children in Africa. Further research will be required to determine how best this vaccine is delivered to SMC and SMC vaccination in areas of seasonal malaria areas in sub-Saharan Africa. Substantial protection against malaria was sustained over the 5 years. And this has been shown in the other paper, which I shared, the Lancet paper. So that's all about the presentation. And I will spend a few minutes to accept questions if you have any before we jump into the next one. So I will accept questions if you have any.
Yeah, hello.
Hello, Mubarak. Yes, I can hear you.
Thank you, Doctor. I think it's a very nice paper. Actually, very interesting issue, especially in African context. As paper discussed and found, even the results and discussions are well written, and I think it will be very relevant recommendations. But I couldn't see the discussion that this malaria, this combination strategy has to be done in a good and in a public as well as in international recommended ways. But simply the research has simply put that it's better than the other ways or other options. So how can can we say something about that? About its implementation.
Implementation. Okay, thank you. Thank you. Let me have one more question from Bikila. Go ahead. Unmute her, you unmute it and then go ahead.
Thank you, Dr. Sunny, for this presentation and for your kind welcoming to join you. And I appreciate your usual cooperation in attending this interesting series. And actually, I've tried to see in the papers, but I couldn't finish it. That is why I did not raise my hand. And I have one concern when we review papers, just when we present papers, the paper might have its own limitation actually, when we see it, just not on the perspective of the researchers, but on our perspectives. The paper might have its own deficit, either methodologically or in any other perspectives. And whenever we are requested to review papers, can we include the limitation of the paper as our own view? Or are we expected just to put the limitations or everything as it is jotted down the paper? Can we add our own? Thank you so much.
Thank you. Just for the sake of time, I'm going to answer these two questions and then we will proceed to our discussion. So, like you said, this is a big trial, a very powerful one. But it's a trial, right? So it only tells you if the vaccine works or not. It doesn't tell you whether the vaccine is very effective in real life and how it is implemented. And implementation studies is being done in parts of Africa. So we are working on implementation study in Ghana, which is a new project. But WHO has approved, and Gavi, which buys vaccine for African countries, has bought the vaccine in collaboration with UNICEF, and it has already supplied the countries for implementation. That was the I think the answer. So implementation studies are still being done because there are problems with vaccine hesitancy and so on. You question, Bikila. So this study, although it's a very powerful one, has its own limitation, and it has also a strength, right? So when you look into a paper, you will always see that. So authors always indicate the weakness of their study as well as the strength of their study. So that's what I tried to show you. So I'm going to go one more time through the paper, and then I will show you how the authors handle that. So I'm going to go quickly. So I tried to show you this one. So if you see, in the first part of the paper, they try to describe the topic. So what is malaria? What is seasonal transmission? What is SMC? And so on. So in the second part, they try to indicate the gap. So these are what has been done in this area. And then again in the introduction, they show the gap again here. Because you see, the vaccine works, but the protection doesn't stay longer. It wanes shortly, which means that it can only be used as a seasonal vaccine with a booster every year, right? So this is the gap and how they want to do the gap. So this is the objective of the study, actually. So how they want to fill the gap. And then the method, so they describe the population, they describe the sampling and so on, and then they describe the exposures. Here is the 3 exposure, right? So what they are going to compare is, so there was another question about non-inferiority. So when we say non-inferiority, we are saying that RTSS is not inferior to SMC group. So giving children only vaccine is not inferior to giving children only SMC with respect to prevention. So this is called inferiority trial. So this is a one-sided test. We will come to that later. The second question is the combined intervention is superior to either the vaccine alone or SMC prevention. So it is not equal, but it is superior. So all the power calculation, the alpha, the beta, they will be different. We will come to discuss that in a later. So this is the exposure. And then they define the outcome. This is how you should do a paper. And this is the statistical method, as well as this one. So remember, so the outcome is not a yes or no outcome, but it is a time to event outcome. So when you have a time to event outcome, you often use a Cox model, which is called survival analysis. So this is the flow chart. One person has asked if there were like days. So here you see that there were 6 people who died, not related to the vaccine. And in the second group, there were 8 children who died. They could have died due to malaria or other causes. And the third one, in the combined group, 3 children had died. But now, because it's a randomized controlled trial, the 3 groups, they are randomized, so they should be similar in all the characteristics. And then this is the outcome. So you see, because it's a time to event outcome, so first you calculate the person year at risk, and then the events. So when you divide events by person year, you will get the incidence and then associated 95% confidence interval. Once you have, so this is, for example, this is the incidence in this group, this is the incidence in this group, and this is the incidence in this group. So if you want to calculate hazard ratio, which is the incidence rate ratio, you will have to divide, for example, if this is the reference group, you will have to divide this one by this one. So when you divide this by this, you will get the hazard ratio for this one. When you divide this by this, you will find the hazard ratio or incident rate ratio for this group. Once you get the hazard ratio, you can calculate vaccine efficacy, protective efficacy, by subtracting from 1 minus the hazard ratio. So hazard ratio is not described here, but you can do with manual calculation. And this column compares the combination group with the vaccine group. So you don't see anything from the other one. So again, it was stratified by country. We see the effect. It was stratified by year, 1, 2nd, 3rd. We did see the effect. So the discussion was presented in such a way that, so you see the first paragraphs were summarizing the findings. This was all about summary of the findings. Once you summarize your findings, and the second thing they did is they describe related research conducted elsewhere. So the association with other research. So this is all about that. And then they started to discuss the limitation of the study, for example, here. And then they came up with the strength of the study. So you see that the study is actually a very strong one. And then they follow up that with the recommendation and conclusion. So that's how the paper was organized. And I think it's an excellent paper. And you can tell that it's published in the New England Journal of Medicine. When you see a paper there, it tells you also the quality of the paper. So I think that's what we have regarding, I think we took quite a long time. We were not supposed to take long. Hopefully we'll take about 1.5 hours. So we will go to the method section. So if you have any question, you can ask in the coming sessions, right? Are you okay? Are you fine? Shall I go to the method session? Are you fine with the paper or any questions?
Yes.
Okay.
Yes.
Yes.
So like I said, the next sessions will be, the first part is epidemiology. The second part would be statistics, and I will show you some news. So like we said, this is a randomized controlled trial. And then when we hear about randomized controlled trial, we always see things like randomization, blinding, comparability, causation, and potential outcomes, as well as missing data. As you can imagine, we cannot discuss all this in 30 minutes, but I will give you quick highlights, and then we will discuss this in detail in the coming sessions. So we do have 2 types of studies, right? One is observational studies, and the other is intervention studies or trials or experimental studies. So when we think of observational studies, it could be a descriptive or analytic. we could have data on groups or data on individuals. So when we have data on groups, we call it a cluster study. So intervention studies could be done in groups, like for example in classrooms, or in veterinary medicine. For example, you can look at herds. In human medicine, you can look at clinics and so on. But you can also look at individuals, such as the study that we just saw. So randomized controlled trials, they are prospective studies. So they measure the effectiveness as well as efficacy of intervention, which is the extent to which a treatment, or it could be a procedure, or it could be a service, does patients more good versus harm. So this is called the benefit harm analysis. So subjects for the trial are randomly assigned to one of the two groups, or it could be one of the three groups or the four groups, depending on your design. And so some children will be assigned to the experimental group, so they receive the intervention, and other children will be assigned to the control groups or the comparison groups. And the groups are then followed over time to see whether they develop an outcome or not. So you have time as well as you have outcomes. So this is how it looks like. So you have a population. From that population, you take samples, and then using randomization, many types of randomization techniques, you randomize children into group 1 versus group 2. So one group will receive the treatment, the other will receive the control, and then you follow them up, and then you see how many children develop the outcome in the first one and how many children develop in the second one. Now, so these two children are randomized. So the difference between these two groups is that these groups received the treatment, these groups didn't receive the treatment. So that should be the only difference. So if there is any difference in outcomes between the two groups, we are able to attribute to the treatment, right? So on average, the two groups will have similar age, similar sex, similar comorbidities, as well as co-medications. That's the benefit of randomization. Randomized controlled trials are the most stringent way of determining a cause-effect relationship. Randomization balances characteristics between the groups, like we said. So it eliminates selection bias. It also minimizes confounding bias. The next component of randomization is blinding. So blinding is the concealment of group allocation from one or more individuals. So the children, the investigators, as well as the statisticians will be concealed. So that's called blinding. So they wouldn't know which children are they don't know which children are in the treatment group and which children are in the intervention group. Could you mute it, please? Could you mute? Thank you. So we're going to take a quick example of what is RCT. So let's say A is exposure. Like we said, it could be a vaccine, it could be a drug, or it could be a service, right? So A is 1 if that subject is exposed. A is 0 if that subject is unexposed. So this is the treated, this is untreated. And then we have an outcome called Y. So Y is 1 if the subject experienced the outcome, otherwise it's 0. And then we have what is called potential outcomes. So potential outcomes are not the actual outcomes. So this is the actual outcome, but these potential outcomes are the counterfactual outcomes. So the outcome under the exposure, A is equal to 1, is represented as Y1. And the outcome under no exposure is represented as Y2. You're following me, right? So, so based on this, we are going to see what a causal estimation is. So we said that you have a population of interest. And some people are treated like A is equal to 1, and others are not treated. A is equal to 0. So now we define what is a causation and what is association. So both are important words in epidemiology. So causation means what will happen if everyone here, everyone is treated, A is equal to 1, versus if everyone is untreated. So this is the potential outcome under treatment versus the potential outcome under no treatment. So causation is, it has to do with what if situation, right? So potential outcome situation. Whereas association, it always deals with the factual outcome. So what is the comparison of outcomes in the treated versus in the untreated? So it doesn't compare what if everyone is treated versus what if everyone is not treated. So association and causation are different in that way. Now, this is the problem. So you see the first column. So these are individuals, and this is their exposure status. So for example, the first person is unexposed, and then Hestia is exposed, Hera is exposed, Apollo is unexposed. So exposure is 0 if not exposed, 1 if exposed. Now, the actual outcome that we have observed is this person didn't have the outcome, whereas Kronos, they did experience the outcome. So this is the factual outcome. So these two are the potential outcome. So if this person was untreated, he or she wouldn't have the outcome. What would happen to this patient if the subject was treated? You see? So this is the outcome of this individual under no treatment, and this is the outcome of this individual under treatment. If we know the outcome of this individual under no treatment and under treatment, we will be able to answer the causal question. But like you see, because this person could be either treated or not treated, we will only observe one of the two. You see, the first subject, for example, it is unexposed. So we will be able to observe only the outcome, the potential outcome under no exposure, this one. If we take this example, Hestia, she is exposed. And then we are only able to observe the potential outcome under exposure because she's exposed, right? So why this is the actual outcome? We observed the potential outcome under exposure. So we don't know what would happen to this patient if she is not exposed. You see? So what you see here is, this is the exposure. Again, I'm going to say it again. This is the outcome, and this is what happened under exposure, and what would have happened under no exposure, what would have happened under exposure. And you see that some data is missing. So that's why Holland, a premier epidemiologist, he defined that causation is a problem of missingness. So this data is missing. For example, all the question mark that you see is missing. So what we are trying to do is we are trying to impute this one. So how do we impute this one? We assign some individuals in the control and other individuals in the treated groups. So those individuals in the treated group will give us information on the control group. You see? So if this individual is assigned to the control group, this individual is assigned to the treated group. So individuals in the treated group, they provide us with the potential outcome under treatment, and individuals assigned to the control group will provide us the potential outcomes under no treatment. And then we will be able to compare the two groups. Once we have that, we can calculate the effect using risk difference. What you see here is the risk difference. And so the null hypothesis is risk difference is 0. And what you see here is risk ratio. So the outcome, this is the probability of the outcome, in the treated versus the probability of the outcome in the untreated. So two risks. So this is the risk ratio. Null hypothesis is ratio is 1. And what you see here is this is the odds of the outcome in the exposed on top, and the odds of the outcome in the unexposed, and the two odds gives us the odds ratio, and the null hypothesis is that the odds ratio is 1. So randomized controlled trials do have drawbacks. One, they are very expensive, and then they do have problems with loss to follow-up as well as missing data, and then they could have problems in generalizability, because if the trial participants are different from the population we want to infer our findings, we might have issues. And so that's all I have on randomized controlled trials. If you have any question on that, I will accept 1 or 2 questions, and then we will jump straight to R. So our time is going, but we will try to minimize. Since this is our first session, we might run a bit late, but we will improve in the next session. So I will accept 1 or 2 questions on the methods, and then we will jump to the statistical part. Mohammed, I can see your hand. You can go ahead.
Thank you so much, Dr. Sani, for your good work. Can you hear me? Please, can you confirm?
Yes, Dr. Mohammed, I can hear you. Yeah.
Okay, thank you. I put my question on the chat box, but I will repeat it because you cannot see in the chat box. And it's that, do you think there would be a change in the results if the authors applied triple blinded instead of a double blinded? Thank you.
Thank you. That's interesting study. So just to answer your question, so sometimes terminologies have changed over the years, right? So they say that a double blind. So in the past, it used to be you have a single blind study where you only blind the participants. So in this case, only children will be blinded, so they don't know if they have received the vaccine or the SMC or the combined one, right? So they don't know. So they are blinded. So this is called a single blind study. And then you could have a second type of study called a double blind, where you blind the children, so they don't know what they are given, but you also blind the physician, so the doctor who is giving the injection or the medication. So children and the doctors are blinded. So the advantage is that so the physician will treat all the children as equal. So if he observes outcome, he will not choose between children. Otherwise, if he knows the vaccination status of the children, then he will give care more to those children who have the actual vaccine compared to the placebo, right? So that avoids the bias. So if the pathologist, for example, is looking into the slide, he would expect a positive slide on those who are not vaccinated. So he will bias the findings, so the outcome. So he will misclassify the outcome. So that's an advantage. A triple blind study is that you blind the children, so they don't know what intervention they receive. You blind the physician, but you also blind the statistician. So the statistician doesn't know which group is SMC group, which group is the vaccine-only group, which group is the combined vaccine and SMC group. But in these times, in the past few years, double-blinded is used for a triple blind study. So because the statistician is also the investigator, right? So when you blind the physicians, you also blind the investigator. So the statistician will know the groups only after finalizing the analysis. So once he has finalized, so I've done similar kind of study. So I didn't know which is the actual intervention, but the data is coded as 0, 1, and 2. So once I do all the analysis, I will be told that what is the true exposure status. So just like you said, it will change the result. But this trial, it's called double-blinded, but it's actually a triple-blinded, just the way you explain it. So if the statistician is not blinded, he might be biased in doing the analysis. So it's always recommended to blind all the participants, the physicians, and all the investigators, including the statistician. Thank you. So just for the sake of time, I'm going to take you to the statistics. So first, I'm going to share the R. So today we are going to see, we are going to look at R, a little bit of R, and then I will share some news about grant applications and conferences and some fellowships that you may consider for yourself. Now I am going to share you R. And you will let me know if you see my screen. So do you see my screen?
Yes.
Okay, thank you. And so this is R Studio. As you can see here, it's R Studio. R is a good statistical package. It's more than a package compared to other packages such as SPSS, SAS, Stata, or others. Like it's more or less close to MATLAB or Python. So the first thing that you do is so the way it works, I don't know how many of you, let me stop sharing this and then see how many of you have installed R. How many of you have used R? How many of you have installed R? Have you all installed R? So could you raise your hand? Okay. Ababa, Bikila, anyone? Hayat? Have you installed R? Okay. So how you go about it is first you have to install. I think it should be in the Telegram, in the Telegram channel. Quickly, let me see. So we have shared how to sorry.
It is available on the Telegram channel.
Oh, it is available. Yes. So I think some of them might. Could you share it, please?
I didn't get the R application.
Okay, I'm going to tell you quickly, and then yeah, I think our time is.
Yeah, there is only document, Dr. Hamsani, but just I couldn't find the.
Okay, so this has been shared in the Telegram channel. So R is a free software. It's not just a software. Actually, it's more than SAS or Stata. It does a lot compared to statistical softwares. So what you do is you have to use this instruction. So you go to R. If you Google R, you will find this. So could you mute? Could you mute? Yeah, thank you. So, ይቅርታ ጋር እየረበሻችሁን ነው። አንዳንዶቻችሁ ሚዩት ብታደርጉልን እንዳንረበሽ ሚዩት አድርጉትና ማውራት ትችላላችሁ። Thank you. So this is the document. So once you see the R ላይ ትሄዱና Rን ካገኛችሁት በኋላ Rን ዳውንሎድ ታደርጋላችሁ. if it is for Windows or Mac Rን ዳውንሎድ ካደረጋችሁ በኋላ ኢንስቶል ታደርጋላችሁ. ኢንስትራክሽኑ እዚህ ያለላችሁ ሁሉ ይሄን ስቴፕ ተከትላችሁ once you install R አርን መጠቀም ትችላላችሁ። እዚህ ስቴፕ ላይ ሁሉም ያልቃል። አርን መጠቀም ትችላላችሁ። አር ምናልባት በደንብ የሚመች ነገር አይደለም። ካያችሁት የሆነ ጥቁር ነው ስታዩት፣ ብዙም የሚያምር ነገር የለውም። ይሄ ማለት ነው አር። ይሄ እንዲያምራችሁ እና በደንብ እንድትሰሩ ከፈለጋችሁ ደግሞ you go to the next step. so አር ስቱዲዮ ላይ ትሄዱና አሁንም አር ስቱዲዮን ትፈልጉና ፍሪ ቨርዥኑን ዳውንሎድ ታደርጋላችሁ። ዊንዶውስ ከሆነ የምትጠቀሙት ለዊንዶውስ፣ ማክ ከሆነ የምትጠቀሙት ማክን ዳውንሎድ ታደርጋላችሁ። ልክ የመጀመሪያውን አር ኢንስቶል ስላደረጋችሁት አር ስቱዲዮ ያንኛውን አር ነው የሚጠቀመው። ስለዚህ ይሄኛውን አር ስቱዲዮን አሁን ኢንስቶል ታደርጋላችሁ። ኢንስቶል ካደረጋችሁ በኋላ አርን መጠቀም ትችላላችሁ ማለት ነው። ሶ እዚህ ጋር ኢንፎርሜሽን አለላችሁ የአር ስቱዲዮ ኮምፖነንት። ስለዚህ እኔ የተወሰነ ሃይላይት ሰጣችኋለሁ ለዛሬ። ዛሬ ዳውንሎድ ያላረጋችሁ ካላችሁ ለኔክስት ታይም ዳውንሎድ አድርጉና ፕሮፐርሊ አጭር ሴሽኖችን አር ላይ እንይዛለን ማለት ነው። so this is how our studio looks like. so የመጀመሪያው ፓርት እዚህ ጋር የምታዩት ፓርት ታይፕ የምታደርጉበት ነው። you can type here. so this is called ስታታ ላይ ዱ ፋይል የምትሉት ነው። እዚህ ጋር ይሄን ሴቭ ማድረግ ትችላላችሁ። እዚህ ጋር እንደምታዩት እኔ ብዙ ዱ ፋይሎች አሉኝ። ኤኒ ታይም ስፈልግ ይሄን ነው የምጠቀመው። እዚህ ጋር ደግሞ አውትፑታችሁን የሚሰጣችሁ ኮንሶል የሚባለው ነው where you see the output። ለምሳሌ ይሄንን 1 ሲደመር 2ን ረን ባረጋው ረን የሚለው እዚህ ጋር ነው። ረን ሳረጋው do you see 1 ሲደመር 2 3 ይሰጠኛል። እዚህም ጋር ማድረግ እችላለሁ። 1 ሲደመር 2 3 ይሰጠኛል። እዚህ ጋር ታይፕ ያደረኩትን ግን ሴቭ ማድረግ አልችልም። ስለዚህ እዚህ ጋር ብጽፈው ኢስ ዱ ፋይል ይሄንን ሴቭ አድርጌ ሌላ ጊዜ ረን ማድረግ ከፈለኩ ረን ማድረግ እችላለሁ። ሶ አር እዚህ ጋር ዱ ፋይላችሁ ነው። እዚህ ጋር ደግሞ አውትፑታችሁን የምታዩበት ነው። እዚህ ጋር ደግሞ የሰራችሁትን ሂስትሪ የሚጽፈው ነው። እዚህ ጋር እንደምታዩት 1+2 እዚህ የሰራሁት በሙሉ it's recorded over here. so this is the history and then there is environment, there is connection and so on. so this is another panel. This is important panel. so this is where you see the graphics or plots. excuse me, mute ያልሆናችሁ mute አርጉልን please. consistently mute አርጉት። mute ያልሆናችሁ mute አርጉልን please እንዳትረብሹን። so እዚህ ጋር እንደምታዩት anything የምትጽፉት እዚህ ጋር ይሆናል። ከዛ በኋላ እዚህ ጋር የምትጽፉት በሙሉ ታይፕ ስታደርጉት ይመጣል። 1+2 ብያለሁ። እዚህ ረን ሳደርገው 3 ሆኗል። ይሄንን ኮድ ነው ሼር ያረኳችሁ። ካያችሁት ሼር ያረኳችሁ ይሄን ፓርት ነው ዱ ፋይል የሚባለው ማለት ነው። ይሄንን ረን ብታረጉት you will find the outcomes here. you will also see plots here. so አራት ሜይን ዊንዶዎች አሉት ወይም ፓነሎች አሉት። the first one is where you type. this is called a do file ወይም ደግሞ ሲንታክስ ኮድ የምንለው ነው የአር and this is where you see the outcome. ለምሳሌ አናሊሲስ ምናምን ሲኖር እዚህ ጋር አውትካሙን የሚሰጣችሁ ኮንሶል ይባላል። and this is your history and environment and this is your plots. so if you want to install package or if you need help it is here. ለምሳሌ student test መስራት ማወቅ ከፈለጋችሁ you will find it here. so R has unlimited help here. please mute አርጉልን ማይክ mute ያላረጋችሁ ካላችሁ ሁላችሁ mute አርጉልን please. so quickly I'm going to go over here. so the first one is 1+2. let's see what it does. so 1+2 it's 3, right? so this is SQRT. so if this is 5 times 6, so this is like the calculator, it's 30. so what do we do? if we do square root of 4, if I run here, this run is you click it to run, the square root of 4 is 2. this is where you get the answer. and this is log of 100. so the logarithm of 100 is 4.6. so this is like rep 3. it replicates 3 10 times. so if you run you see this, so it replicates 3 how many times? 10 times. and this is 1+2 which we wrote. and sometimes you can store 1+2 in a subject called A. so this means like store it in A. so if I click this one, you don't see the answer, right? 1 plus 2 is 3, but what we see is it runs only and it doesn't show you the answer. So if I type A here, if I type A down there, I will get 3. So 1 plus 2 is stored in A, so A is 3. So this is like store 1 through 10. So if I run only the selected part, it will run this part. But if I click in this line and then run it, it is stored in B. So if I select B and run B, it shows B is 1 through 10. So this is how you store result in R. So if I store, this could be written as 1 through 10. So if I run this again, you see, I tell R to store 1 through 10 in a subject called C. So if I run C, this is 1 through 10. So if I run B, this is 1 through 10. And if I run C, it's the same, 1 through 10. I can also create data. So for example, I replicate 2 5 times. Rep is like replicate. This is how I get. And then I replicate 3. How many times? 7 times. And then I replicate 4. How many times? 5 times. You see? 5 times. And then I replicate 5 3 times. But I can combine this. So this is combine all this. So if I combine this, it gives us 2 is replicated 5 times, 3 7 times, 4 5 times, and 5 3 times. Okay, so I see. So this C1 through 10, it means the same as the above one. So C1 through 10 is the same as the above one. So sometimes I don't see your text. So I will. So if I run this, look. So this is 1 through 10. So if I type 1 through 5, 1 through 15, it will give me this one. So if I type 1 through 100, I will get this one. So yeah, that's how it works. Now look, I want to store this using Edge. So this is the name of this data. So if I click this, so it runs this one, but it doesn't give you the result. It stores in a variable called Edge. So now if I run Edge only, so it is giving me all these results. So Edge is now. So if you call Edge, if I ask what is Edge, R will give me this. So R has stored it in its memory, right? Now I want to, a good example would be, for example, so let's say like how many students have taken the grade 12 exam. It's around 500,000, right? So if I store this, so R only gives me the first 500 data because there is no space, you see? So I asked R to list 1 through 500,000. You see, like this is a big data, right? This is a very big data. So what we always want is we want to summarize this data. Like giving this data is to someone is very confusing because it's like 500 observations. So you always want to summarize. When you want to summarize, you want to tell where is the majority of the data. Where is the majority of the data? And that's called location. But you want to also know that how these data are distributed. So how they are spread against this central observation. And that's called the spread or the variation. So this is how we're going to do. So we know Edge is, now we know Edge is this individual. So if I run Edge, it gives me these individuals, but I want to calculate the mean. So R knows what mean is. So if I type mean in bracket Edge, R is calculating the mean of this one. You see? But if I don't know do it mean, I can ask help from R. So to ask help, you type question mark and then you say like help. Or you can also say like min. I need help on min. So do you see here in this one, R is giving me help. So min is, you can calculate min as min and then the data point. So this one is more easier when you get used to R. So this is how, so if I ask R what min is, R is telling me that it is an arithmetic mean. You see? So if I ask R about SD, and R will tell me SD is a standard deviation. So to calculate standard deviation, I should type SD and then provide X. If there is missing data, then I should tell R to ignore the missing data. That's if it is missing, then ignore it, just calculate the non-missing part. So and then I'm gonna show you here. So if I run this part, remember, so this is the mean of those values here. So the mean of these values is 3.3, but we also want to see how these numbers are distributed across this mean. So, and then if we need the median, we still can run the median. So the median is 3. So median is the 2, because it's even number of observation. It's like the middle observation, or the mean of the 2 middle observation. So if I type SD, standardized difference is 1.03. You see, now we have the mean, we have standard deviation, and then we can calculate the 95 percentage range. We will come to see that later. So in R, I think one important thing that I should mention is in R uses memory, right? So when R uses memory, usually you have to tell R where to store the result, or you have to tell R where to look into the data. So this is how you're gonna do that. So if I ask R get the working directory, you see, this is like get is get, W is working directory. So where is all this stored? So R is telling me that everything you do is gonna be stored in users, Sunny, in documents, in the folder serology. So this will tell you where R is storing your data. So if I ask R to import data, it can read data, Excel data, Stata data, any kind of data, and R can import the data in here, but it will need to know where that data is stored. So I will have to set the directory. So set directory is this one. If you want to set the directory, for example, like, okay, I'm going to set the directory like this. Probably if I like this. Now R is not looking into serology. It will only see in this folder, in my documents, right? So I have mislaid R. So if I want to store results in a certain folder, I should tell R the specific folder, and that's called serology. Okay, serology. Is that all clear? So this is how you find the path to your storage. This is how you tell R to use a new folder. So the second part is playing with the data, and then we will see what is mean and confidence interval. So I will take 5 minutes. I will try to take 5 minutes for that. So like I said, R norm is random normal distribution. So if I type this one, you can play with this one. So I think you have to play to learn R. So if you see that I am asking R, please generate 5 1000 observation because it's a random one. And then with a normal distribution, a mean of 11, a standard deviation of 11. So if you need what R norm is, you can type here, like I told you, help R norm n. So that's the beauty of R. So it will tell you R norm is a normal distribution, and this is how you define it. So R norm, this is the sample size, this is the mean, and this is the standard deviation. So if you see here, so the sample size is 5,000, the mean is 11, the standard deviation is 5. And I'm going to store this in what? In M data. So if I run the whole line, so I'm gonna run it again. Sorry. So if you play with this data, I think you can play. It works well. So I've generated for you. So this is, I'm gonna run the first line. Okay, I think I have a problem. Let me see. So እዚህ ጋር ለምሳሌ ይሄን መርጬ ረን ካረኩት በአማርኛ ልንገራችሁ። ይሄ የዚህ ችግር ምንድነው? እዚህ ረን ካረጋችሁት ስቶርድ አይሆንም፣ ሜስ ያደርግባችኋል። ራይት ሜስ እንዳይፈጥር ይሄንን ስቶር ታደርጉታላችሁ። ምን ብላችሁ? ኤም ዳታ ብላችሁ ማለት ነው። ሶ ኢፍ አይ ረን ኦል ዲስ ኦንሊ ዘ ፈርስት ፓርት ሰሌክት ካረኩት ረን የሚያደርገው ኦንሊ ዲስ ሰሌክትድ ፓርት ነው። ክሊክ ብቻ ካረኩ ግን it will run that line. You see the difference? So if I like click here at the end or here, it doesn't matter. R will run that line. Okay. So Ziga ሌላው you can set your working directory. ቅድም እዚህ ጋር set ያልኳችሁ I'm going to set it, choose a directory ይላችኋል, and then you can specify the folder. So I'm going to set in my documents folder, and then I have a file called serology. So I will use that. Okay. Now I should be fine. So this is how I'm going to run. Maybe select largo na lahon does it run largo. You see? Now what is አሁን የመጀመሪያዎቹን 10 data points ስጠኝ ካልኩት it will list the first 10 observations. You see here? So if I ask R 1 through 10, it will give me the first 10 observations. If I ask R what is M data, so select አርጊያንን ብቻ run ካረኩት it will give me the first 1000 observations. So there is no space እያለኝ ነው R. ስለዚህ እኔ የምፈልገው የመጀመሪያዎቹን 10 ብቻ ስለሆነ I will run the first 10 lines, and this is the first 10 observation. Now the second part is, well, I want to see the distribution, right? So if I type here histogram, I want to see the histogram. So if you need help, this is how you type. And R tells you, okay, if you want to plot histogram, then use hist and then specify the data. Okay, then I'm going to specify the data. You see this one, this line? I type hist and then I provided the data. So if I run only this line, you see, it plots it. So these are from the other plot. So let me run it again. Okay. Now you see the histogram of my data looks like this. So on the x-axis, it is the data points. On the y-axis, it's the frequency, how many times those individuals appear. Are you following? Are you following? Is that all clear?
Yes.
Okay.
Yes.
So
Yes.
yeah. So አሁን histogram ነው የፈለኩት። histogram አርግልኝ ስለው histogram አርግልኝ። አያችሁት አይደል? አሁን ቦክስ ፕሎት ብለው let's try እስኪ ቦክስ ፕሎት እንበልና ሰርች እናርግ። ቦክስ plot. R, it takes time to learn. a little bit time ግን ፐርፌክት መሆን አትችሉም መቼም ምክንያቱም it's very advanced programming ነው ግን it's very friendly ከምታውቋቸው ከስታታም ከስፔስስም even ከሳስም በጣም friendly ነው ልክ ይሄን አርግ እንደ you can communicate with R so it's easier you can do any kind of analysis including artificial intelligence such as data mining but then it has a sharp a steep learning curve ትንሽ ጊዜ ይወስዳል ለመማር ግን let it be it's worth the effort ይታያቸዋል አይደል አሁን ቦክስ ፕሎት ስለው ኦኬ ቦክስ ፕሎት ከፈለክ ቦክስ ፕሎትን ጻፍና ዳታውን ፕሮቫይድ አድርጋለህ ከዛ የተለያየ ነገር ከፈለኩኝ እንደዛ ያረኩ መቀጠል ይችላልው ማለት ነው okay now what I want is the summary of this data you see okay now I know what summary is but if you want to know what summary is in R አሁንም እዚህ ጋር ነው ሄልፕ የምጠይቀው you see okay summary ከፈለክ ቤዚክ ላይ አለ ይለኛል አልሰጠኝም እዚህ ላይ so ግን ሰመሪውን ረን ባረጋው እቺን ብቻ መርጬ ረን ባረጋት what do you expect from the summary the 5 number summaries you see the minimum value the first quartile the second quartile which is the median the mean the third quartile and then the maximum so box plotaችሁ የሚጠቀመው እነዚህ ነው አይደል ሚኒመሙ ማክሲመሙ and then box አምታዩት ላይ እስኪ box plot እንበለውና እንጠይቀው ከሰራልን box plot አረኩኝ and then I provided the data okay ያቻላችሁ አብረን ረን ማድረግ እንችላለን ቦክስ ፕሎት የምትለዋን እቺን ብቻ ልምረጣትና ረን አረኩት you see box plot እንደሰራልኝ ይሄን ግን ማሳመር ይችላልው ከለር ምናምን አሁን ጂጂ ፕሎት የሚባላል አር ላይ that's the best graphic statistical software package የፈለጋችሁትን ማድረግ ትችላላችሁ so once you are used to R usually እኔ የምጠቀመው አሳያችኋለሁ ምን አይነት ፕሎቶች እንደምሰራ ጂጂ ፕሎት ነው የምጠቀመው ጂጂ ፕሎት can do a miracle for you so this is how it works አሁን የሚቀጥለው ላይ need አሁን የዚህን ሚን ፈለኩኝ so I want to calculate the mean is 11 you see when I generate the data I told R to generate a normal distribution from a normal distribution with mean 11 and the standard deviation 5 you see now if I ask the standard deviation what do you expect it is 5 you see now this is let's say this is the population አይደለ አሁን ወደ ታች እንውረድና አርን ልጠይቀው አሁን አርን ምን ይያልኩት ነው as data frame m ዳታን ውሰድና እንደ ዳታ ፍሬም አርገህ ስቶር አርገው አልኩት ምን ብለህ m ዳታ ብለህ ስቶር አርገው ብዬ ይሄን ረን አረኩት አሁን r ይሄን የሚያየው እንደ ዳታ ነው look the difference I'm going to type here for the sake of easiness አሁን የመጀመሪያዎቹን 10 ኦብዘርቬሽን ሮዎቹን ነው የጠየቁት ኮማ አረኩኝ ማለት እንደዚህ ነው አያችሁት አሁን እንደቀድሙ ቀደም የመጀመሪያዎቹን 10 ስለው it gave me a result now let's see it doesn't give me a result you see the difference because now R is a data frame it has rows it has columns so we have to specify the rows and the columns before this R ዝም ብሎ ሪካርዶች ነበር a list ነበር ስለዚህ የመጀመሪያዎቹን 10 ስጠይቀው it just provide me the 10 observation ታስታውሱ ከሆነ እዚህ ጋር ያያችሁት you see this one እዚህ ጋር አርን ከ1 እስከ 10 ያሉትን የመጀመሪያዎቹን 10 ኦብዘርቬሽኖች ስጠኝ ስለው it gave me the 10 observation እዚህ ጋር ግን አልሰጠኝም ምክንያቱም አርን ምን አርገዋለሁ እንደ ዳታ ፍሬም አርጋ ሴቭ አርገው ይያለሁ which means the R has a row as well as a column ስለዚህ ዳታ ፍሬም ማለት ሁለት ዳይሜንሽን አለ a row and a column so this is where I specify this one so you see this አሁን አርን እንትን ያልኩት የመጀመሪያውን ኮለምን ነው ኮለምኑ አንድ ስለሆነ የመጀመሪያውን ኮለም ነው የሚሰጠኝ ኮለምኑ አንካልኩት it's the same whether you specify it or not column 2 ብለው wrong ነው የሚለኝ ምክንያቱም ሁለተኛ ኮለምን የለው it has only one column it has 5000 rows that clear right now I'm going to ask R dimension so you see here dime data So R is telling me that your data, M data, has 5,000 rows and 1 column. እያለኝ ነው። ዳይሜንሽን መጠየቅ ከፈለኩኝ አሁንም ይሰጠኛል። ዳይሜንሽን ከፈለክ ዳይም አርግና ዳታን በለው ይለኛል። just like I did it. So የመጀመሪያዎቹን አስሮቹን አየን right? ከዛ አርን ምን እያደረኩት ነው? what are the column names ብዬ ልጠይቀው ወይም ደግሞ ምን ማለት column names ማለት what are the names of the column of M data ነው የምለው። R is case sensitive ነው እንደምታውቁት ያመጣላችኋል። አንዴ ከጻፋችሁት ያንን ተጠቅማችሁ ኮለምኖቹ ምንድናቸው ስትሉት አይ M ዳታ ነው ይላል። ኮለምን የለውም። okay I want to change the column, so call names R M data ውሰድና column nameውን age በለው አልኩት right? So I'm going to run this. So run አረገው አላሳየኝም ሪዛልቱን። now I'm going to do the previous one. previously M data ነበር ያለው አይደል? አሁን what are the names of the columns of R ነው የምለው። አያችሁታ? now it's age. So if you want to see what names are እዚህ ጋር አርን መጠየቅ ትችላላችሁ። names ማለት column nameዎቹን ነው የሚሰጣችሁ ብዙ ጊዜ። so let's go to the next one. So we know now it's age of 5,000 children saved as a data frame. Now ምን ብለናል? አሁን ቀደም ታስታውሳላችሁ አይደል? mean of M data ስንል አግኝተናል። አሁን አርን what is the mean of this data ብለን ጠይቀው። it's wrong ይለናል። error እንደዛ የሚባል ዳታ የለም ይለናል። ምክንያቱም አሁን ዳታ ነው and then the column name is age. So this one the dollar sign ምን እያላችሁ ነው? in this data M data look at the age column እያላችሁት ነው። የምትፈልጉትን column specify የምታደርጉት በዶላር ሳይን በመጠቀም ነው። so calculate the mean of the data for the age column. so M data ላይ ሂድና የኤጅን mean calculate አድርግልን እያልነው ነው። so this is how it calculated. so calculate ያረከውን mean data ብለህ ስቶር አድርገው እያልነው ነው። ይሄኛው ደግሞ ይታያችኋል። M data ላይ ሂድና መጀመሪያ meanን calculate አድርግ የኤጅን and then store it እዛው ዳታ ላይ mean ብለህ ስቶር አድርገው እያልነው ነው። so this is how I run አርጋችሁት ከሆነ አሁን ደግሞ እስኪ የመጀመሪያዎቹን 10 ኦብዘርቬሽኖች አሳየኝ እያልኩት ነው። so this is I type የመጀመሪያዎቹን 10 ኦብዘርቬሽኖች አሳየኝ 10 ሮዎች ኮለምኑን ስፔሲፋይ አላረኩትም። ስለዚህ ያለውን ኮለም በሙሉ ይሰጠኛል ማለት ነው። አያችሁት? so የመጀመሪያዎቹ 10 ኦብዘርቬሽኖች እነዚህ ናቸው። the name of the first column is age and the second column is the mean of the age. ይታያችኋል? every column ላይ the same mean ነው። ምክንያቱም አንድ ዳታ ነው። ሚኑ አንድ አይነት ነው። are you following me?
well
Yes.
Okay. Yes.
Okay. So this is how friendly R is. So now we're going to go to the next step. So if I type the same thing, look, the first column in አርግና ሁለተኛውን ኮለምን ስጠኝ ካልኩት የቱ ነው የሚሰጠኝ? ሁለተኛውን ኮለም ብቻ ነው የሚሰጠኝ። if I change this the first 20 ኮለምን የመጀመሪያዎቹን ሁለቱን ለማድረግ ከፈለኩኝ 1 and 2 ከዛ እንደገና አንድን ደግሞ ሶስተኛ ኮለምን አርጋ አንጣው ካልኩት ሲ ማለት ኮምባይን አርጋቸው ማለት ነው። so አርን ከ1 እስከ 20 ያሉትን መጀመሪያ የመጀመሪያውን ኮለምን የሁለተኛውን ኮለምን እንደገና የመጀመሪያውን ኮለምን አርጋ አንጣው ብለው this is how it gives me. አያችሁት? 20 ኮለምን ሰጠኝ። ከዛ የመጀመሪያው 20 rows and then the first column, the second column, and then I ask him the first column. So if I ask R first column, second column, first column, and second column, and then second column አርገህ ስጠኝ ብለው አያችሁት የሚሰጠኝ 20ዎቹን ሮዎች ሰጠኝና and then the second column, the first column, the second column, the second column. This is mean. So you can call which column የፈለጋችሁትን ኮለምን በዚህ መልኩ መጥራት ትችላላችሁ ማለት ነው። okay, that's it. So this is more of our introduction. አሁን ምን ማድረግ ፈለኩኝ? mean calculate የምናደርገው እንዴት ነው? So we usually calculate mean. First, we calculate the mean. We have already calculated that. So the second thing we do is the deviation. Deviation is defined as how far is individual observations from the mean, right? So how far is this individual from this mean? So we subtract this from this. So this is how we do it. So like I said, we always call the ይሄኛው ካለ ረን አያደርገው like እንደዚህ እንዳለ ሃሽ ማርክ አለ ማለት ይሄን ላይን ረን አታርገው ማለት ነው። አሁን ረን ባረጋው እዩት። if I run አያደርገውም r, but if I only select this one እዚህ ክሊክ አድርጌ እንትን ካልኩ ይሄን ነው የሚያየው የመጀመሪያው because it's a hash mark ረን አያደርገው። ግን ይችን ብቻ ሴሌክት ካረኳት r will run it። ምን እያለኝ ነው? m1 m data 1 የሚባል የለም እያለኝ። do you see? m data 1 የሚባል የለም እያለኝ ነው። ስለዚህ what should I do? m data 1 የለም እያለኝ ነው። so what should I do? Okay, let me take this one. Okay, just for this practical, m data 1 m ዳታን ውሰድና m data 1 ብለህ ሴቭ አድርገው እያልኩት ነው። m data 1 ብለህ ሴቭ አድርገው አልኩት። so if I type m now እዚህም ጋር ታይፕ ማድረግ እችላለሁ። m data 1 ብዬ ታይፕ ካረኩኝ የመጀመሪያዎቹን 10 ኦብዘርቬሽን ስጠኝ ካልኩት m data 1 የለም እያለኝ ነው አሁን። okay, just a second. Okay. M data 1 is m data 1 ብለህ ሴቭ አድርገው እለዋለሁ። I'm going to run. So m data, so if I type m data አለ, so m data 1ም አለ ማለት ነው። It's just the same as m data አይደል? So this is where we are now. so ጥያቄ ካላችሁ በማይክ እንትን በሉኝ፣ ቴክስት ቻት እያየሁ ስላልሆነ። so m data አለን. then what we want to do is now we want to calculate the deviations. so take the m data, አሁን አረን እያልኩት ያለው m ዳታን ውሰድና ዲቪዬሽን የሚል ቫሪያብል ክሬት አድርግ እያልኩት ነው። so ስታታ ላይ ጀን እንደምትሉት ማለት ነው። ጀነሬት ዲቪዬሽን የሚባል ቫሪያብል ጀነሬት አድርግ። ጀነሬት ስታረግ ግን ምንድነው ያልኩት? ከሚን ላይ ኤጅን ቀንስ። so ከዚህ ሚን ላይ እያንዳንዱ እንትን ኤጅን እየቀነስክ አስቀምጥ አልኩት። so ይቺ ዶላር ሳይን it takes this variable። ይሄን ከዚህ ዳታ ውስጥ ይሄን ቫሪያብል ከፈለግን በዶላር ሳይን ነው እንትን የምንለው። so let me show you this one. so the first እንደዚህ አድርጌ በጠይቀው የመጀመሪያዎቹን 10 ኦብዘርቬሽን ስጠኝ ብለው ሮንግ ነው የሚሰጠኝ። ለምን እንደሆነ ነግራችኋለሁ። ምክንያቱም ይሄ አንድ ሮ ነው። ከኤም ዳታ 1 የዚህን ስጠኝ ካልኩት አንድ ሮ ስለሆነ ኮለምን መኖር የለበትም። just one row for data ነው። አንድ ዳይሜንሽን ብቻ ስላለው ማለት ነው። so ከዛ ይሄን ወስጄ ደግሞ ይሄን ኤጅ ባረገው ሚን ሳይሆን ኤጅ ባረገው ከኤም ዳታ 1 ኤጅ ቫሪያብልን ውሰድና የመጀመሪያዎቹን 10ዎች ስጠኝ ካልኩት የሚሰጠኝ እነዚህን የመጀመሪያዎቹን 10ዎች ነው። አያችሁታል? so ምን እያልኩት ነው አሁን? ከሚን ላይ ከእያንዳንዱ ሚን ላይ subtract age አልኩት። ከዛ ምን አድርገው አልኩት? store it as a deviation አልኩት ማለት ነው። so I'm going to run this one። አሁን ረን አድርጎት አያሳየኝም፣ ግን ስቶር አድርጎታል። ያንን ቼክ ለማድረግ ከፈለኩ I go back to m data 1 and then አያችሁት ኮለምኑን ስፔሲፋይ ስላላረኩት it will give me all the columns. you see the first column is age, second column is mean, the third column is deviations. So deviations ብዙ ጊዜ deviations የምንላቸው how far is this observation from the central one, the mean ማለት ነው። Okay, so sorry, it took longer. Now ምን እያልኩት ነው? Like if we calculate this one, average of the deviation ስንት ነው የሚሆነው? 0 ነው። ምክንያቱም all the positives and all the negatives will cancel out. ስለዚህ that's why we want the square of the deviation. So አርን ምን እያደረኩት ነው? deviation squared የሚል variable create አድርግ አልኩት። So deviationን በdeviation አባዛውና you see this is the same thing. deviationን በdeviation አባዛውና times is like asterisk in R. So deviationን በdeviation አባዛውና deviation square ብለህ ሴቭ አድርገው አልኩት። You see? And then now, okay, how does the data look like? Now, you see, now it adds a new column, and that's called deviation square. Okay, now we have the data. በሌላ መልኩ ምን ማድረግ እንችላለን? This is more advanced one. ይሄን ሁሉ ከምጽፍ ቀለል እንዲላችሁ more program ስታረጉ m ዳታን ውሰድ ከዛ ሚውቴት አድርገው ብለዋለሁ። ሚውቴት አድርገው ማለት ከሚን ላይ ኤጅን ቀንስና ዲቪዬሽን ብለህ ሴቭ አድርገው። ከዲቪዬሽን ላይ እንትን ቀንስና ብለህ ሴቭ። እስካሁን ረን ያረኩትን በዚች መጨረስ እችላለሁ። this is another option። ከዛ ልክ እንዳልኳችሁ የመጀመሪያዎቹን 10 ኦብዘርቬሽን ረን አድርግ ብለው sorry it's running all. So just hold on for a minute, right? Can you hear me? So we are here now. What we have learned in statistics is once we have the deviations, the square deviation. Now, what's the variance? What's the variance? So the mean of these deviations, right? So if we type the mean of data is m data, and then square deviations. The mean of R will help you deviation squared. Sorry, if I type data one calculate, usually R ከጀመርኩለት ይጨርስልኛል። deviation አያችሁ deviation squared ስለሆነ ይሄን ታይፕ አደርጋለሁ። The mean of the deviation squared is 25. The problem with this, the variance is mean is measured, for example, age ነው አይደለ? So mean measure የተደረገው በየር ነው። ይሄኛው ግን variance ግን year squared ነው እኛ የምንፈልገው ግን በሴም ዩኒት ነው ስለዚህ we take the square root of this one so if we take the square root of this one SQRT we get 5 ይሄ ያየነው standard deviation ነው ማለት ነው so do you see the difference so this is how you can use R and then like I said if I want to calculate the 95% interval what I do is first I calculate the mean age which is 11 and then I can use a Z distribution or T distribution which is plus or minus 1.96 the standard deviation of age so let's calculate the standard deviation of age which is 5 so if I run these two lines so the mean plus or minus 1.96 standard deviation of age so this is like 20 so this is the upper limit this is the lower limit ይሄ confidence interval አይደለም it is confidence 95% bound ነው የሚባለው I think you can run the rest of the table so if we run these values what we get is the same like we can find a range of values the box plot የሚሰጠን and then you can try this one አሁን እዚህ ጋር ፔስት አድርገው እያልኩት ነው ይሄን ላይን ካያችሁት ፔስት አድርገው እያልኩት ነው መጀመሪያ ሚን ኤጅን ካልኩሌት አርክ minus 1.96 the standard deviation arc በኮማ ለየው then ይሄኛውን አርኩት if I run it so it's like it will paste it as it is so I'm not going to go through all but you can do that yourself so I think I will stop here and then go to the statistics part so if you have any questions I could accept one or two questions
for each of efforts and also which is very important for maximizing
so mute አርጉትና እጅ አውጥታችሁ አንድ ጥያቄ ልቀበልና ወደሚቀጥለው ሴሽን እንሄዳለን
and continuous properties of support supervision
do you have any question difference between range and confidence interval I think ምናልባት እዚህ ሴሽን ላይ ከቨር ላናረገው እንችላለን maybe let me use what
for myself and also in the verge of
could you mute
አራሽናፊ ሚውት አድርገው
I'm a bit frustrated because the time has gone maybe የሚቀጥለው ላይ ላሳያችሁና ጥያቄ ካላችሁ በኋላ እንመለስበታለን let me see quickly ልሂድበትና ሌላ ጊዜ የምንመለስበት ይሆናል so ዛሬ ሼር አረጋቸዋለሁ ያልኩት ሌላው ይሄ ነበር ቀደም እንዳየነው we might want to know where the central point is so that's the location ይሄ usually mean ነው ወይም ደግሞ median ነው and then how they are spread የሚለውን የሚነግረን ደግሞ standard deviation ነው ቀደም እንዳልኳችሁ የስታንዳርድ ዲቪዬሽን ጥቅሙ ከቫሪያንስ ይልቅ the same unit ነው ያለው ከኤጅ ለምሳሌ year ነው ይሄኛውም year ነው ቁመት ከሆነ በሜትር ነው ስታንዳርድ ዲቪዬሽንም በሜትር ነው ቬሪያንስ ችግሩ ቁመት በሜትር ለከታችሁ ቬሪያንስ ግን ሜትር ስኩዌር ነው ስለዚህ ለዛ ነው ስኩዌር ሩት የምናወጣው ማለት ነው so then we might have to discuss about a population and a parameter so population እና parameter ልዩነታቸው ምንድነው population the whole set ነው census የምንለው ነው ነገር ግን if we want to test a hypothesis or if we want to estimate we take a sample of it because we cannot use the whole population for many reasons ከኮስት አንጻር ከታይም አንጻር ethics አንጻር we cannot do our study in the entire population so we take a sample of it that's called sampling and then we test our hypothesis or we do the estimate in the sample but the focus is the population so the sample is not important it's only used for estimation or hypothesis testing once we have that we infer or generalize to the population ማለት ነው again ግልጽ ነው አይደለ so ብዙ ጊዜ statistics epidemiology ላይ የምንሰራው ምንድነው either we test a hypothesis or we make estimations ያው በታይም እጥረት ምክንያት population ማለት እንደዚህ ነው population ይኖረናል we take a sample then when we take a sample because this is smaller than this one if we take another sample the estimates will differ and then if we take another sample it is slightly different if we take another sample it would be different so there is variation between samples so ከነዚህ for example we can estimate different means so the means would be different slightly but they are not very different so when the sample size gets larger so the means from each sample they get closer but all these estimates they are called statistics and they are estimates of the population parameter so population is sent mean ያለው አንድ mean ብቻ ነው ያለው we don't know that mean so we are trying to estimate that mean so what we do is we keep sampling but this is not allowed right so we only take one sample but if we had taken many samples we can tell the uncertainty that is associated with our sample ያንን uncertainty sampling variationን ለመንገር ምን እንጠቀማለን ብዙ ጊዜ clinical trial ካያችሁ አንድ sample ነው የምትወስዱት አይደል you cannot sample 100 times ስለዚህ ምንድነው የምታደርጉት 100 sample ብትወስዱ ኖሮ the distribution of that mean will have this interval so confidence interval report ስታደርጉ ብዙ ጊዜ ይሄንን 100 ጊዜ sample ብታደርጉ ምን ይመስላል የሚለው ነው የሚነግርላችሁ 100 ጊዜ sample አታረጉ ማረግ አንችልም we only have one sample but our confidence interval gives an insight of how the 100 sample look like I think next class ላይ እንትንለዋለን so የmean እና standard deviation meaning ይሄ ነው ቅድም ያሉን observations we said that we have 5000 observations so the mean is the central point እዚህ ጋር ያለው ነው ብለናል ከዛ standard deviation ማለት how they are spread ነው ልክ አሁን ይሄ normal distribution ነው የቅድሙ ሂስቶግራሙን አይታችሁታል አይደል ያ ማለት አንድ standard deviation ስንት ነው አንድ standard deviation what is our standard deviation in the data 5 አይደለ ታስታውሳላችሁ ቅድም ካልኩሌት ያደረግነው ስለዚህ ሚናችን ስንት ነው 11 ነው ስለዚህ 63% የሚሆኑት ልጆች ወይም whatever 63% የሚሆኑት ልጆች ኤጃቸው ስንት በስንት ውስጥ ነው they are one standard deviation from the mean on both sides one standard deviation from the mean on the left and one standard deviation from the mean on the right one standard deviation ማለት 5 ነው so 10 is the mean 11 is the mean plus 5 17 so this value will be 17 and this value would be 11 minus 5 it would be 6 so between 6 and 17 63% of the children are here but two standard deviation ብንወስድ ደግሞ two standard deviation ማለት ስንት ነው አንድ standard deviation 5 ነው ሁለት standard deviation 10 ይሆናል ማለት ነው so 95% የሚሆኑት ልጆች ከሚኑ በስንት ርቀት ላይ ነው ያሉት ማለት ነው ሁለት standard deviation ወደ ግራ and then two standard deviation ወደ ቀኝ two standard deviation ማለት 10 1.96 ስናጠጋጋው ማለት ነው 1.96 ሁለት አርገን ብንወስደው ሁለት ሲባዛ በ5 10 so 10 plus 11 21 so between 21 and 11 minus 10 between 1 and 21 this is 1 and this is 21 95% of the children are within this is not confidence interval አይደለም ያወራን ያለን ግልጽ ነው አይደል አሁን confidence interval ካወራን ምንድነው like we said that in the previous slide ምን ብለናል አንድ ሳምፕል ብንወስድ ያ ሳምፕል የራሱ confidence interval ይኖረዋል ሌላ ሳምፕል ብንወስድ የራሱ ሚን የራሱ confidence interval ይኖረዋል ይሄ ሳምፕል ስንወስድ የራሱ ሚን የራሱ confidence interval ይኖረዋል you see አሁን የእያንዳንዱ ሚን የነዚህ ሚኖች 100 ሳምፕል ቢኖሩ 100 ሚኖች የራሳቸው ዲስትሪቢዩሽን አላቸው አይደለ ያ ዲስትሪቢዩሽን እንደዚህ ነው so መቶቹ ሚኖች ደግሞ የራሳቸው ዲስትሪቢዩሽን አላቸው የራሳቸው ሚን አላቸው መቶቹ ሚኖች ደግሞ የራሳቸው ስታንዳርድ ዲቪዬሽን አላቸው የሚኖቹ standard deviation it's called standard error ይባላል የልጆቹ የእያንዳንዱ observation standard deviation ይባላል የሚኖቹ ደግሞ standard deviation ምን ይባላል standard error ይባላል ስለዚህ 100 ሚኖች ብንወስድ 63% የሚሆኑት ሚኖች ከመቶቹ 63ቱ within one standard error from the mean ይሆናሉ and 95% of the means would be two standard error from the mean do you understand so አሁን ስለ multi distribution እያወራን ነው ማለት confidence interval ሁሉ ጊዜ is about a multi distribution I think I will stop there and then so the idea was to look at hypothesis testing but we will look at this one next time so I'm going to quickly go to the next step and this is how we're going to do the next time we usually plan to do this in 1 hour but it may not be feasible but we will try to stick to 1 hour and I do really apologize because this is our first session it's kind of a trial session so we will try to share with you conferences grant calls scholarships job and networking opportunities so for today I'm going to share you a few things so upcoming conferences AIDS like research የምትሰሩ ሰዎች ካላችሁ the next conference in 2024 is in July and it will be in Munich Germany abstract summit የምታረጉ ከሆነ abstract deadline 23 of January ነው ስኮላርሺፕ ይሰጣሉ በተለይ ደግሞ ዴቨሎፒንግ ካንትሪ ሴቶች ላይ ላሉ ኢቭን ጋዜጠኞች ሶሻል ሳይንቲስቶችም ስኮላርሺፕ ማግኘት ይችላሉ the scholarship usually covers for young researchers as well as clinicians travel award አለው accommodation አለው registration for free አለው it's a big conference ነው ይሄን ዴድላይን ወሰዱት ሌላው ኢስፐ ሜዲሲን ላይ የምትሰሩ ካላችሁ ወይም ደግሞ ሄልዝ ኢኮኖሚክስ ላይ የምትሰሩ ካላችሁ ኢስፖር ነው ኢስፐ በሚቀጥለው አመት በርሊን ነው የሚሆነው እነዚህ ቨርቹዋል እንትንም አላቸው ትራቭል ሳታረጉ ቨርቹዋሊ ጆይን ማድረግ ትችላላችሁ ግን you need scholarship as well ብዙ ጊዜ ከዴቨሎፒንግ ካንትሪ የሚመጡ ይሰጣሉ እኔ ሴሌክት ያደረኳቸው ስኮላርሺፕ የሚሰጡትን ነው በብዛት ኢስፐ ኢንተርናሽናል ሶሳይቲ ኦፍ ፋርማኮ ኤፒዴሚዮሎጂ ነው ድራግ ላይ የምትሰሩ ሰዎች ካላችሁ ቫክሲን ላይ እነዚህ ብዙ ጊዜ ስኮላርሺፕ ይሰጣሉ አብስትራክት ሰሚት ካረጋችሁ ደግሞ በጣም አድቫንቴጅ ነው ኢስፖር ሄልዝ ኢኮኖሚክስ ላይ የምትሰሩ ካላችሁ ኢስፖር ክፍት ነው next year ኢስፖር is I think in Seattle now in Seattle Washington US deadline almost the same now I think this one is about ወደ ጃንዋሪ ነው ሁለቱም ስኮላርሺፕ በጣም ይሰጣሉ ስፔሻሊ አብስትራክት ሰሚት ላረጉ አብስትራክት ዴድላይኑ ፌብሩዋሪ 14th ነው ስኮላርሺፕ ዴድላይናቸው እኔ ይሄን ተማሪ ያለው ሞክሬዋለሁ ወደ 1-6-7 ጊዜ ስኮላርሺፕ አግኝቻለሁ በዚህ ተማሪ ከሆናችሁ they just give you scholarship for free especially abstract ካላችሁ and don't be afraid we will help you with that ይሄኛው ለብዙዎቻችሁ የሚሆነው American Society of Tropical Medicine and Health this is annual conference zoonosis ላይ የምትሰሩ ካላችሁ rabies ላይ TB parasitic infection ቬቶች clinicians nurses anyone interested in the next conference is in New Orleans Louisiana ነው ከኦክቶበር 23 እስከ 27 ነው I think early next February ላይ ስኮላርሺፑ ኦፕን ይሆናል እስከ ፌብሩዋሪ ጊዜ ያላችሁ ማለት ነው ለማዘጋጀት አብስትራክትም ካላችሁ እስከዛ አዘጋጁት ስኮላርሺፕም ካለ በደንብ አፕሊኬሽኑን አዘጋጁትና ከዛ በፊት አፕላይ ታደርጋላችሁ ይሄኛው ሌላው አድቫንቴጅ this has a fellowship for 1 year or 2 year የሚቆይ ፌሎሺፕ አለ ወደ $50,000 ነው የሚሰጡት I think last year a student from Kenya has won it travel conference አለው ሜንተር ይቀጠርላችኋል and then it's easier for African low and middle income student ነው ይሄኛው ብዙ አይነት ፌሎሺፖች አሉ ይሄኛው ግን for young low and middle income country ነው ስለዚህ mostly African applicant ነው ይሄን ዊን ያደርጋል I think for today that's all about the conferences so if you need help with abstract submission we will help you in one of our sessions ትንሽ ስኮላርሺፖችን ልንገራችሁና አልፋለሁኝ PhD ተማሪ ካላችሁ ማንኛውም ሳይንስ ተማሪ የዩኬዎቹን ነው ለአሁን መሰጣችሁ ዌልካም ትረስት ላይ ፎሪ ፒኤችዲ ስቱደንትሺፕ አለ አኑዋል ነው ያገኙት ኢትዮጵያዊ ተማሪዎች አሉ ይሄንን PhD ተማሪዎች ካላችሁ there is a PhD fellowship for health professionals it includes nurses public health professionals vets and all clinicians and this is also easy and then there is a master scholarship for humanities and social science demography law ምናምን ላይ የምትሰሩ ካላችሁ ይሄኛው ጂኦግራፊ ላይ የምትሰሩ ካላችሁ human geography ላይ different university ይቀበላሉ ከኢትዮጵያ የመጡ ተማሪዎች አሉ last year በዚህ scholarship and then you have all the career award programs in ይሄኛው MRC welcome and MRC ናቸው እነዚህ for your PhD scholarship fellowship አለ career development award አለ እንደገና PhD fellowship for health professional አለ ይሄ በየአመቱ የሚሄድ ነው if you need help again we will help you in one of our sessions I think grant apply ማድረግ የምትፈልጉ ካላችሁ ለአፍሪካ አገሮች ብቻ የሚወጡ ስኮላርሺፖች አሉ ብዙ ጊዜ እነዚህ በረታታሉ ለምሳሌ UKRI adolescent health within global health research አለ እዚህ ላይ maternal health child health ላይ የምትሰሩ ወይም ደግሞ addiction ላይ ትራፊክ አክሲደንት ላይ የምትሰሩ ይሄኛው ኦፕን ነው የሚዘጋው ፌብሩዋሪ 13 አካባቢ ነው ሌሎቻችሁ ደግሞ MRC አካባቢ ፌብሩዋሪ ላይ የሚዘጋ አንድ ራውንድ አለ እንዴት አፕላይ እንደሚደረግ መማር ከፈለጋችሁ on the 7th of December there is a webinar register ማድረግ አለባችሁ MRC ዌብሳይት ላይ ሄዳችሁ the webinar is free and the total amount is more for this one and then these are the welcome trust fellows so in the next session we will provide you with more information on this one so we apologize we took longer than we expected next time ላይ አሻሽለን እንደገና እንመጣለን እናንተም የምታውቁት ስኮላርሺፕ ካለ ቀድማችሁ ላኩልን እዚህ ጋር እየተዋወስን እንተጋገዛለን ማለት ነው I think that's been a very long session 2 hours so if you have questions I will accept few and then we will end the session thank you ጥያቄ ካለ አርም ላይ ጥያቄ ካለ አር ሼር አድርጌዋለሁ ቫይብራኒየም ሪሶርስስ ቴሌግራም ቻናል ላይ ሼር ያደረኳችሁን ረን አላረግነውም ሰዓት እጥረት ስላለ እናንተ ረን እያደረጋችሁ ሞክሩት ከዛ next ላይ we will have a follow up so next session in 2 weeks now I think we will have a paper on mathematical modeling of COVID published paper a scholar from Imperial College I think will present for us and then we will have a methodological discussion statistical discussion and then a discussion on scholarships grants and so on
may I ask one question doctor
go ahead
okay thank you very much I was actually your student in Harama University and Daniel I'm very happy for this today's discussion but I'm a little bit confused about standard error and standard deviation would you say something about it thank you
standard deviation thank you Daniel let me wait for another question I think that's a very good question so standard error and standard deviation so maybe we'll have one more question and then I will answer it together any other question any other question
would you please share us basic codes on the commands
they are already shared they have been shared before a week practice አርጋችሁት እንድትመጡ ሼር አድርጌዋለሁ so ምክንያቱም there is no other way to share I think you will have to go to Vibranium Resources Telegram channel እዛ ላይ ሁሉ ማቴሪያል አለ ፔፐሩ all the papers all the other codes and all the instructions how to install R and R Studio እዛ ላይ አለ ሌላ ጥያቄ ያለው አለ any question እጁን ያወጣለ so go ahead take the mic አበበ Dr. Ababa. So I use first name, so feel free to use my first name
No, it's okay. Yeah, thank you for this introductory session. So I will be. It's not a question, but I'm a bit now. Currently, I'm in Belgium, so I will be back to Ethiopia after a week. But in Ethiopia, the time. Do you think the time is okay at 7 p.m.? Because for the sake of internet issues, people will be too much people will be following you, or maybe the session, if it is during the daytime. It's like 10 a.m., 5 a.m., then they can be at office but due to internet issues. The second question is, the first one is not a question. The second, this one is, some people, they use standard error to tell the significance of the association or whatever. So maybe, or are we ahead of your session? If not ahead of the session, can we use standard error for such purposes? That's the question. Thank you.
Okay. Thank you, Abba, Dr. Abba. So may I have another question, the third one, and then I can answer together. So this is our first session. So you have seen the paper. So they have used confidence interval, right? So they have used confidence interval. So whatever complicated the design is, whatever complicated the analysis is, there is always sampling, there is always standard error, standard deviation, and confidence interval. So we're gonna learn this through the session. So band ጊዜን ጨርሰውም ስለዚህ ምናልባት ፍቃዱልኝና በአማርኛ ልንገራችሁ። You're right? ስታንዳርድ ኤረር እና ስታንዳርድ ዲቪዬሽን ልዩነቱን በአማርኛ ልንገራችሁ። ታስታውሱ ከሆነ ፖፑሌሽን ላይ ሜዠር ማድረግ የምንፈልገው ነገር በሙሉ አንድ ነው። ሚን ከፈለግን የፖፑሌሽኑ ሚን አንድ ነው። ስታንዳርድ ዲቪዬሽን ከፈለግን የፖፑሌሽኑ ስታንዳርድ ዲቪዬሽን አንድ ብቻ ነው። ሪስክ ሬሽዮ ከፈለግን፣ ኦድስ ሬሽዮ ከፈለግን፣ ኤኒቲንግ ፕሮፖርሽን ከፈለግን in the population it is only one. We don't need confidence interval. ስለዚህ the problem, we don't know the parameter. ያንን ፓራሜትር ነው ምንል፣ ግን ያንን ፓራሜትር ስለማናውቅ የመጀመሪያ ስራችን ምን ይሆናል? ሳምፕል እናደርጋለን ማለት ነው። so የሳምፕል ጥቅሙ የፖፑሌሽኑን ፓራሜትር ኤስቲሜት ማድረግ ብቻ ነው፣ ወይም ደግሞ ሃይፖቴሲሳችንን ቴስት ማድረግ ነው እንጂ ሳምፕል በራሱ ምንም ጥቅም የለውም። The problem is, if we take a sample and then if we calculate the mean, we will get one mean. But we are not sure because it's sample. Because ሌላ ሰው መጥቶ አንድ ሳምፕል ቢወስድ he will get a different mean. ሌላ ሰው መጥቶ ሌላ ሳምፕል ቢወስድ he will get another mean. አያችሁት አይደል? የተለያየ ሳምፕል ብንወስድ አሁን በዚህ ላይ ስንት ሚኖች እናገኛለን? አራት የተለያዩ ሚኖች እናገኛለን። ሳምፕል ሳይዛችን በጣም ትልቅ ከሆነ እነዚህ አራት ሚኖች ይቀራረባሉ። ገባችኋል? ሳምፕል ሳይዛችን ስሞል ከሆነ እነዚህ ሳምፕል እንትኖች ይለያያሉ። አሁን ከነዚህ ካልኩሌት የምናደርጋቸው ኳንቲቲዎች ምን እንላቸዋለን? they are statistic. እነዚህ statistics, they are all estimates of the parameter which we don't know. It's one parameter. ያንዱ ፓራሜትር ያንዱ ሚን ግምቶች ናቸው። ግን የተለያየ ሳምፕል ስናደርግ ግምቱ ስለሚለያይ we want to tell the uncertainty around that estimate አይደለ? ሪሰርች ስትሰሩ መቼም 100 ጊዜ ሳምፕል ማድረግ አትችሉም። ኤቲክሱም አይፈቅድላችሁም፣ ኮስቱ። ስለዚህ ምንድነው የምታደርጉት? ስለ አንድ ሚን አንድ ሳምፕል ነው የምትወስዱት፣ ግን አንሰርቴኒቲውን ሪፖርት ማድረግ አለባችሁ አይደለ? 100 ሳምፕል ብትወስዱ ሚኑ እንዴት ነው ዲስትሪቢዩትድ የሚሆነው? ለዛ ነው ሳምፕሊንግ ዲስትሪቢዩሽን የሚባለው። አሁን we take sample አንድ 100 ጊዜ ብንወስድ እነዛ ሚኖች 100 ሚኖች ይኖሩናል። እነዛ ሚኖች የራሳቸው ዲስትሪቢዩሽን አላቸው። ግልጽ ነው አይደል? መቶዎቹ ሚኖች የራሳቸው ዲስትሪቢዩሽን አላቸው። ሪሜምበር ሳምፕል ውስጥ ምን አለ? ኦብዘርቬሽን አለ። አሁን ይሄ ሳምፕል 2000 ነው ሳምፕሉ ብንል 2000 ልጆች የራሳቸው ሚን የራሳቸው ስታንዳርድ ዲቪዬሽን አላቸው እዚህ ደግሞ 2000 ናቸው እነዚህ ደግሞ የራሳቸው ሚን የራሳቸው ስታንዳርድ ዲቪዬሽን አላቸው ሚኖቹን ብቻ ብንወስድ እዚህ አንድ ሚን አለ እዚህ ሌላ ሚን አለ እዚህ ሌላ ሚን አለ we have 100 ሚኖች አሉ ለ100 ሳምፕሎች in practical we only have one mean ስለ 100 ሚኖች ለማወቅ ምን እንጠቀማለን ዲስትሪቢዩሽን እንጠቀማለን ግልጽ ነው 100 ሳምፕል መውሰድ ስለማንችል we rely on distribution የሚቀጥለው ስላይድ ያንን ነው የሚነግረን sorry so ቅድም እንዳልነው ኖርማል ዲስትሪቢዩሽን የሚጠቅመን ለምንድን ነው ይሄ አንዱ ሳምፕላችን ቢሆንና 2000 ናቸው ያልናቸው ሳምፕል ሳይዛቸው 2000 ነው ብንል ሚኑ ሴንተር ላይ ነው የሚሆነው ልጆቹ ደግሞ ዲስትሪቢዩትድ የሚሆኑት sorry ኖርማል ዲስትሪቢዩሽን ከሆነ 63% የሚሆኑት ልጆች they will be distributed around this mean ከሚኑ በአንድ ስታንዳርድ ዲቪዬሽን ርቀት ውስጥ ነው የሚኖሩት ከላይና ከታች ማለት ነው so this is one standard deviation this is one standard deviation አያችሁት አንድ ስታንዳርድ ዲቪዬሽን ማለት 5 ነው ብለናል 5 ይር ማለት ነው ስታንዳርድ ዲቪዬሽን እና ሚናችሁ the same unit ላይ ያለው ብዙ ጊዜ ስለሚጠፋ ነው ኤጅ ነው ካል 11 ነው ሚኑ ስለዚህ ስታንዳርድ ዲቪዬሽኑ 5 ነው አንድ ስታንዳርድ ዲቪዬሽን ማለት 5 አመት ነው ማለት ነው ሁለት ስታንዳርድ ዲቪዬሽን ማለት 2 ታይምስ 5 10 ነው ማለት ነው ስለዚህ 63% የሚሆኑት ማንኛውም ዲስትሪቢዩሽን ኖርማል ዲስትሪቢዩሽን ከሆነ 63% የሚሆነው ኦብዘርቬሽን ከሚኑ በአንድ ስታንዳርድ ዲቪዬሽን ርቀት ላይ ነው ያሉት 95% የሚሆኑት ደግሞ በስንት ርቀት ላይ ነው 1.96 almost 2 ብንለው ብናጠጋጋው ሁለት ስታንዳርድ ዲቪዬሽን ርቀት ላይ ነው ያሉት ያ ማለት ነው ሁለት ስታንዳርድ ዲቪዬሽን ማለት 10 years ማለት ነው ከሚኑ 10 years 11 ሲደመር 10 እና 10 years ወደታች 11 ሲቀነስ 10 አያችሁት እዚህ ጋር የተጠቀመው ምንድነው ካያችሁ the mean plus or minus the statistics እዚህ ጋር z 1.96 times the standard deviation የተጠቀመው እዚህ ጋር አሁን እየተናገርን ያለነው ስለ ኮንፊደንስ ኢንተርቫል አይደለም የኦብዘርቬሽኖቹ በምን ያህል ርቀት ውስጥ አሉ ስለ ሬንጅ ነው ያወራን ያለነው ግልጽ ነው አይደል አሁን let's forget it now we are talking about samples አሁን አንድ ሳምፕል ወሰድን ሌላ ሳምፕል ወሰድን 100 ጊዜ ሳምፕል አረግን እንበል እነዚህ 100 ሚኖች የራሳቸው ዲስትሪቢዩሽን አላቸው አይደል የሚኖቹ ሚን አለ ግራንድ ሚን እንለዋለን እዚህ ጋር ነው የሚሆነው ከመቶዎቹ ሚኖች 63% የሚሆኑት የ63ቱ ሳምፕሎች ሚኖች 63ቱ ሚኖች ማለት ነው በስንት ርቀት ውስጥ አሉ one standard deviation from the grand mean ውስጥ ነው ያሉት አያችሁት 95% ማለት ነው ከመቶዎቹ ሳምፕሎች 95 የሚሆኑት ሚኖች ደግሞ within 1.96 ነው አሁን እያልን ያለነው ምንድነው ሚን አለን we are taking the standard the ሚኖቹ ደግሞ ዲስትሪቢዩትድ የሆኑበት የራሳቸው ስታንዳርድ ዲቪዬሽን አለ ሶ የሚኖቹ ስታንዳርድ ዲቪዬሽን ስታንዳርድ ኤረር እንለዋለን ግልጽ ነው እያንዳንዳቸው within our sample ያለው ስታንዳርድ ዲቪዬሽን ነው የምንለው በኦብዘርቬሽኖች መካከል ያለው በሚኖች በተለያዩ ሳምፕሎች ሚን ውስጥ ያለው ቫሪዬሽን ስታንዳርድ ኤረር እንለዋለን ሶ ኮንፊደንስ ኢንተርቫል የምናወራ ከሆነ it is about ስታንዳርድ ኤረር ነው ምክንያቱም አሁን ኮንፊደንስ ኢንተርቫል ስንሰራ ኔክስት ስላይድ ይኖረናል ምናልባት እዚህ ጋር ላሳያችሁ እነዚህ አሁን so we know the population mean is 30 100 ጊዜ ሳምፕል ብናረግ እና 100 ጊዜ ኮንፊደንስ ኢንተርቫል ብንሰራ እነዚህ እናገኛለን so the dot የምታዩት the mean ነው ላይኑ የምታዩት ደግሞ upper and lower limit ነው ስለዚህ 100 ጊዜ ሳምፕል ወስደን 100 ኮንፊደንስ ኢንተርቫል ኮንስትራክት ብናረግ 95 የሚሆኑት in blue they will contain the single parameter that's 30 ገባችሁ ከመቶዎቹ 95ቱ ፖፑሌሽን ፓራሜትሩን ይይዙታል ማናቀው ማለት ነው ኤስቲሜት ማድረግ የምንፈልገው አምስቱ ደግሞ በቀይ ያሉት they will miss it እኛ ደግሞ ምን አርገናል አልፋን ካስታወሳችሁ when we calculate the alpha we allow 5% error 5% ከመቶ 5% ሚስቴክ ለመቀበል ፈቃደኞች ነን V alpha type 1 error is 5%. Our confidence interval ይሄን ሚን የሚይዘው ከሆነ የኛ ኮንፊደንስ ኢንተርቫል ስንት ነው ያለን? አንድ ብቻ ነው አይደል? ከአንድ ሳምፕል ከአንድ ሳምፕል we will only have this confidence interval እንጂ 100 አይኖረን. So if our confidence interval contains the mean, which is the true mean, this one, we can say that የኛ confidence interval አንዷ ከ95ቱ አንዷ ነች. 95ቱ true parameterun የሚይዙት confidence intervaloች ናቸው, which we don't know. የኛ አንዷ confidence interval ግን ከነዛ ከ95ቶቹ አንዷ ነች. ስለዚህ significant ከሆነ ከ95ቱ significantዎች የኛ አንዷ ነው ማለት ነው. ስለዚህ we can reject ከአምስቱ አንድ አይደለችም. የኛ ግን significant ካልሆነ ከአምስቶቹ አንዷ ነች ማለት ነው. Do you get it? So we don't reject ማለት ነው. ስለዚህ ሁሉ ጊዜ እኛ reproduce የምናደርገው confidence interval ከ95ቱ confidence intervaloች true parameterun ያ አንድ የሆነውን true የማይታወቀውን አንድ ፓራሜትር ከሚይዙት 95 ኢንተርቫሎች ውስጥ የኛ አንዷ ነች ማለት ነው. ስለዚህ የኛ significant ከሆነ 94 ሌሎች significantዎች አሉ ማለት ነው. ስለዚህ ሪጀክት ማድረግ አንችልም. የኛ ደግሞ significant ካልሆነ significant ያልሆነ ሌላ 94 ማለት አለ ማለት ነው. ስለዚህ our confidence interval is always one of the 95 confidence intervals that contain the true parameter. ስለዚህ confidence intervalን ኢንተርፕሬት ስናደርግ ሁሉ ጊዜ ስለ multiple sampling ነው የምናወራው ማለት ነው. Sorry አራዘምኩባችሁ. I think this will be covered in the coming sessions in detail. R ኮዱን ረን ካረጋችሁት ይሄንን አሳያችኋለሁ. እዛ ላይ ማየት ትችላላችሁ. Actually it's coded in the R code that I shared. I think so difference ምንድነው? standard deviation የምንለው በኤጅ በኢንዲቪጁዋሎች መካከል ያለው ቫሪዬሽን ነው. ስታንዳርድ ኤረር የምንለው ግን በሚን ኦፍ ኤጅ በተለያየ ሳምፕል ብንወስድ በሚን ኦፍ ኤጅ በሚኖቹ በተለያዩ ሚኖች ላይ የሚኖረው ቫሪዬሽን ነው. ካያችሁ ካልኩሌሽኑ ስታንዳርድ ኤረር is equal to standard deviation divided by the square root of n ነው የሚለው. ስታንዳርድ ኤረርን ግን ስታንዳርድ ዲቪዬሽን ግን ከዳታው ካልኩሌት ማድረግ እንችላለን አይደል? ስታንዳርድ ዲቪዬሽኑ ግን 100 ሚኖች ቢኖሩ እነዛ ሚኖች እንዴት ነው ስፕሬድ ያደረጉት? ሶ የሚኖቹ ስታንዳርድ ዲቪዬሽን ነው ስታንዳርድ ኤረር የሚባል። ስታንዳርድ ዲቪዬሽን ግን የኢንዲቪጁዋሎቹ ስታንዳርድ ዲቪዬሽን ነው. I think that answer your question. ሌላው ሰዓት በተመለከተ ምናልባት ይሄ ሰዓት ይቀላል ብለን ነው የወሰነው. I know it's difficult. I don't know what's best for people in Ethiopia. ቅዳሜ ነው ምናልባት ቀኑን ሙሉ ቅዳሜያቸውን ውጭ ነው የሚያሳልፉት. ምናልባት ማታ ነው ረፍት የሚኖራቸው በሚል ነው ታሳቢ ያደረግነው. አስተያየቶቻችሁን ተሰጡንና ምናልባት ይሄ ታይም ኮንቪኒየንት ነው የምትሉ እስኪ እጃችሁን ሬዝ አድርጉና ንገሩ. this time is good የምትሉ Okay, it doesn't seem hey time good አይመስልም. ማሻሻል ይኖርብናል. I don't know the best time for you. ስለዚህ we will have to wait and discuss.
Sorry, doctor.
Yes.
Can you hear me?
Yeah.
I think ብዙዎቻችን ይሄ ታይም በጣም ኮንቪኒየንት ነው የሚመስለኝ። ምናልባት ቅድም የተነሳው ኮንሰርን የኢንተርኔት ነው። እኔ በ25 ብር ኢንተርኔት ነው ሶፋር ፎሎ እያደረኩ ያለሁት። ምናልባት ቀን ላይ በብዙ ስራዎች የምንጨናነቅበት ምሳም ሰዓት ስለሆነ አይ ቲንክ በጣም አይዲያል ታይም ነው ብዬ አስባለሁ ይሄ ታይም እና በዚህ አጋጣሚ ላመሰግንም እወዳለሁ ለታይሙ በዚህ መልክ አደረጋችሁ። በጣም ጥሩ ታይም ነው for honestly speaking.
Okay. Thank you. I think አንድ ሼር ማድረግ የምፈልገው አር ላይ ጀምሩትና stick with it. We're going to master it. ትወዱታላችሁ። ምንም ፍራስትሬት አታርጉ. It's not a competition. I think it will take time. ግን I think it's the best statistical software out there. ሌላ ጊዜ ሼር አደርጋችኋለሁ እኔ ረን ማድረገው ምናምን። So don't be frustrated. ምንም እንትን እንዳይገባችሁ ሁልጊዜ ኮድ ሰጣቸዋለሁ ዳታም ሰጣቸዋለሁ run ታደርጉታላችሁ and then we have I think on December the 2nd we have presenter from Australia on maternal and child health so ሐሳቡ ምንድነው ከተለያየ ዓለም ኢትዮጵያኖች የተለያየ ሪሰርች አይዲያቸውን ፐብሊሽ ያደረጉትን ፔፐር ሼር እንዲያደርጉን writing for publication እንድንማር ዳታ አናሊሲስ እንድንማር እንደገና ደግሞ ፔፐሮችን ማንበብ እና እንዴት ኢንተርፕሬት ማድረግ እንዳለብን እንድንማር I think things like sampling confidence interval standard error they will come again and again and again so repeats ለሚያደርጉ ዛሬ ካልገባችሁ just stay with us it will be clear in the coming years ሌላ አንድ ኦፕሽን ይኖረናል ይሄ በየሁለት ሳምንቱ ነው ይሄ ፕሮግራም የሚቀጥለው ግን ወደፊት በመሃል PhD ተማሪ ሆናችሁ ሳምፕል ሳይዝ ካልኩሌት የማድረግ ችግር ካለባችሁ ወይም ደግሞ ኩዌስችኑን ሪፍሬዝ የማድረግ እንትን ካለባችሁ ዲስከሽን ፕላትፎርሞችን እንፈጥራለን አብረን ዲስከስ ማድረግ እንችላለን ወደፊት ማለት ነው I'm really sorry that this session is very long but yeah we will try to stick to time in the coming sessions any one question ሁለሳ ካለ እናረጋው ነው question ካለ ለመልስና ከምዘጋው so this record is available on YouTube I think Vibranium Resources YouTube ላይ አለ ምናልባት ያለፋችሁ ካለና ክሊር ያሮነ ካለ እዛጋ ቼክ ማድረግ ትችላላችሁ and then if you have question we're going to come up with next so after a paper presentation we will have our data እና stat ሁልጊዜ epidemiology economics mathematical modeling እነዚህ ስኪሎችን አብረን እንወስዳለን so theoretical እንዳይሆን እናንተ ፔፐሩን አንብባችሁ ነው አንደኛ ሁለተኛ ረን አርጋችሁት ነው ኮድ አለ እዛ ተሰጥቷችኋል ስለዚህ ረን አርጋችሁት ከመጣችሁ it will be easier it will save us time as well so yeah that's all thank you from my side one question ካለ ግን መቀበል ይቻላል አንድ ጥያቄ ካላችሁ መቀበል ይችላል we have 2 minutes for okay ጥያቄ ያላችሁ አላችሁ ከአበበ አንድ ድል ስለወሰደ ሌላ ሰው ካለ እሺ go ahead አበበ
ኦኬ ምናልባት ጥያቄው አይደለም የእንትኑ ሐሳቡ ላይ ነውና እኔ ለምሳሌ ጎንደር ዩኒቨርሲቲ ነው ያለሁት በመሰራውና አሁን አብዛኛው ሰው የሚጠቀመው ሪያሊቲውን ማወቅ ስላለብን ብዬ ነውና የዩኒቨርሲቲው የብሮድባንድ ኢንተርኔት አለ አይደለ እሱም ብቻ ነው አክሰስ ያለውና እንደ ጎንደር ዩኒቨርሲቲ በጣም ብዙ ስታፍ ሊጠቀምበት የሚችለውበት ፕላትፎርም ስለሆነ ሚስ ባይደረግ ብዬ ስላሰብኩ ነው ያው ቀዳሜ ገብቶ ማንንም ሰው አክሰስ ማድረግ ይችላል ከዛ ውጭ ከሆነ ግን ያው ዩቲዩብን ነው የምንከታተለው እየገባል
ያ ኢንተራክቲቭ ቢሆን ጥሩ ነው so maybe ይሄድን እናየዋለን ትንሽ ኮንሳልት አድርገን ነው ይሄን ሰዓት የመረጥነው ከሌሎች ጋር አውርተን ነው ራንደምሊ አይደለም ግን ለሁሉም ያው ጥሩ ሐሳብ ነው አበበ ይሰጣል ለሁሉም አይመችም ግን እስኪ እናወራና I prefer the morning እኔም ፕሪፈር አደርጋለሁ ግን ዋናው መድረስ አለበት ሰው ሌላው አንድ ፌቨር የምንጠይቃችሁ የምታውቋቸው ሰዎች ካሉ እንደ ኦዲየንስ እንዲጠቀሙ እናርጋቸው ሼር እናርጋቸው and then I think if they could benefit የተለያዩ ሰዎች ስለሚመጡ I will step back and then we will have other people so more ኤይሙ የሚሆነው እናንተን ሰፖርት ማድረግ ሳይሆን ተማሪዎቻችሁን ሰፖርት ማድረግ ነው at the end of the day ሁላችሁም አስተማሪዎች ናችሁ ግን ተማሪዎቻችሁን ሰፖርት ማድረግ የምንችለው like education qualityውን one way improve ማድረግ የምንችለው በዚህ ነው እና this is a platform not just my platform but it's a network of all Ethiopians in the health sciences ቬቶችም health scienceዎችም everyone social scienceዎችም so አብረን የምንመካከርበት መድረክ ነው ከቻላችሁ ሼርም በማድረግ more people invite አድርጉ thank you so much thank you
okay thank you
have a good so YouTube channelum Vibranium Resources ነው Telegram channelum Vibranium Resources ነው ሁለቱም በዛ ታገኙታላችሁ በጣም አመሰግናለሁ መልካም ምሽት መልካም ዊኬንድ good night